children, I am Pooja Gurung, an assistant geography teacher from St. Teresas Girls Higher Secondary School. So today we are going to start with chapter 1, that is geomorphic processes, the exogenous process and the resultant landform. So first, before directly going into the geomorphic process, the earth in which we are living, it has many unevenness. That means in some places we have mountains, some places we have plain, and in some places we have plateaus. So these are all unevenness that are present on the surface of the earth. So this unevenness is because of the geomorphic processes. These landforms like mountains, plateaus, they are formed because of these geomorphic processes. They are the result of geomorphic process. So the word geomorphic, it is made up of two terms, geo and morphic, where geo means earth and the morphic means the form or the structure. So geomorphic means the earth's form, landform or the structure. So various landforms are present on the surface of the earth. Earth is not a flat or a leveled land, so it has many irregularities, or the surface of the earth is uneven. It has many features on the surface of the earth. So this is all the result of the geomorphic process. So all these landforms which are present on the surface of the earth, these are because of the two forces. First one is the endogenic forces. So here endogenic forces means, endo means internal or inside. So this force is active in the interior of the earth. So this endogenic forces, it is responsible for the formation of mountains, plateaus, cliffs, etc. And exogenous forces, these are the forces which act outside the surface of the earth. So the agents of exogenous forces are the running water, wind, glacier, etc. So they work together. Endogenous and the exogenous forces, they work together to make the surface of the earth plain or a flat or a leveled land. So we will concentrate now in the exogenous forces. So this exogenous force, they work very, very slowly. So they work very, very slowly, and they worn down the highland and deposit that worn down material in the lowland. That means they erode the materials from the highland or the upland, and they will deposit those eroded materials in the lowland and try to make the earth a leveled land. It will try to produce a graded profile of the earth's surface. So it works. Endogenous, exogenous forces, it works with the help of erosion and weathering. So erosion and weathering is the main process which is involved in this exogenous forces. So I told you geomorphic process, because of the geomorphic process there is unevenness on the surface of the earth. So now the process of gradation, the main aim of gradation is to remove the unevenness from the surface of the earth. That means the process of gradation aims to remove all the unevenness from the surface of the earth and make the earth a flat and a leveled land. So this process of gradation, it shows its effect by degradation and aggradation. So degradation and aggradation, these are the two actions which are related with gradation and which helps to produce the flat or a leveled surface, earth surface. So here the first one is degradation. So here the word degradation. Degradation means, let's say in a simple word, it means to subtract. So degradation means to lower the height of the surface of the earth. So that is the definition for degradation. So degradation is the process of lowering down the height of the earth's surface. That means subtraction in the height of the earth's surface. So for example, Aravalli range. Aravalli range, it was a very tall mountain when it was formed, but because of degradation, what happened is the Aravalli range, it lost its height. The Aravalli range, the rock, they started to break, and the height of the Aravalli range, it started to decrease. So in that way, degradation means the lowering down of the height of the earth's surface. So degradation, it works. How the Aravalli range lost its height? So the degradation, it works with the help of three processes. So these three processes which are involved in degradation are erosion. Second one is weathering. And the third one is transportation. So the lowering down of the height of the earth's surface, this is done by these three processes: erosion, weathering and transportation. So because of the weathering, the rocks are broken down, and the weathered materials, they are eroded and they are transported to some other place. So in this way, Aravalli range lost its height. So that means now the process of degradation is trying to make the earth, trying to level the surface of the earth, trying to make the surface of the earth flat and a leveled land. So that is degradation, which means to lower the height of the earth's surface. Next one is aggradation. So here in the aggradation, what happens is there, aggradation means to add, or it just means to build up. So the aggradation is the process in which a landform is built up, it is a process of building up of landform, where in the first case, degradation, the rock has been weathered, the Aravalli range has been weathered, for example. So these weathered material, they are transported to some other place. Okay, so I told you there are uplands. Earth is full of unevenness. In some places there are highlands, and in some places there are depressions or the lowlands. So the height of these highlands are decreasing. So this particular things which is being eroded away or the weathered away, they are being carried on by the running water, wind, glacier, and these materials are being deposited in this depression, and this depression is being filled by the weathered material. So the process, this process of gradation is trying to make the surface of the earth a flat and a leveled land. Now the next topic we are going to do is the weathering. So in a simple language, how we can define weathering is, it is the breaking up of rock. A big rock is there, or a stone is there, and when this rock breaks into pieces, that is known as weathering. So weathering is the breaking up of rocks, or this is the disintegration or the decomposition of rock in situ. Situ means in the place where they belong, in the place where they have originated by the agents like temperature, the heat from the sun, the rain, glacier, wind, etc. So weathering, it is of many types. So mechanical weathering, chemical weathering and biological weathering. So first we'll deal with the mechanical weathering. So mechanical weathering it is a process of weathering, or it is the breaking up of the rocks where no chemical change takes place in the mineral, or without changing the mineral composition. So here in the mechanical weathering, a rock is simply broken into pieces. The chemical reaction does not take place. The composition of the rock do not change. So it is just a rock is there and the rock is broken into pieces. That is all about the mechanical weathering or the physical weathering. It is also known as physical weathering. So mechanical weathering, it has three processes. First one is block disintegration, second one is exfoliation, and the third one is granular disintegration. So first one, block disintegration. So block disintegration, this takes place especially in the dry areas, especially in the desert areas where the range of temperature is very high. That means the temperature is very high during daytime and it's very low during night. So in those places, block disintegration is very common, especially in the desert area. So in the block disintegration, because of the intense heat during the daytime and the very low temperature during night time, the rock, they expand and they contract regularly. During daytime they expand and during night time they contract. This regular expansion and contraction will lead to develop cracks or the joints. Suppose this is a rock, and because of continuous expansion and contraction, a crack will develop on the rock. So through this crack or along this crack or the joint, the rocks will be broken into blocks. So that is known as block disintegration. The name itself is giving you the definition, block. They are breaking into blocks. So that is all about the block disintegration. So this is especially in the dry areas, especially in the desert areas. Next one is exfoliation. So exfoliation is also known as onion weathering. Onion weathering. So here in the exfoliation or the onion weathering, what happens is a rock is there, okay, a rock is there. So the layer of the rock, this rock, they will disintegrate or they will break layer after layer, like the onion. We have seen onion. So onion has many layers. So so like the onion, so the first layer of the rock will be peeled off. It will detach from the main rock, and the second layer again after some time it will detach. So in that way the process of exfoliation is also known as onion weathering. So here in this exfoliation process, the rock, they disintegrate, they break layer after layer. So that is the process of exfoliation or the onion weathering. So that also takes place when the range of temperature is very high. That means very high. The temperature is very high during daytime and it's very low during night. The unequal expansion and contraction that will lead to the peeling up of the layers of the rock, and at last a round shape, a dome-shaped rock will be left there. So that is known as exfoliation dome. Next one is the granular disintegration. So in this granular disintegration, the name itself is saying granular. That means the rock, they are broken into very fine grains of sand or the rock particles. So here in the granular disintegration, the rock are made up of minerals. There are some rock, they are made up of only one mineral, and some rock, they are made up of many minerals. So this granular disintegration happens in the rock which contains many minerals or which are made up of many minerals. So the different minerals, they have different capacity to absorb the heat from the sun. So this difference in the because of of this one, there is a difference in the expansion and contraction of the minerals in the rock, so which will ultimately lead to break the rock into small grains or in a granule. So that is known as granular disintegration. So here last I told you aggradation and degradation, these are very, very important. The difference between aggradation and degradation, that is one of the most important question. So the second type of weathering is the chemical weathering. So chemical weathering is the disintegration and the decomposition of the rock by chemical means. And here the mineral composition, here the composition of the rock is altered or changed, coming in contact with the gases which are present in the atmosphere, or coming in contact with the water, rainwater. So chemical weathering, they change the mineral composition. The mineral composition of the rock is completely changed in the chemical weathering, so the decaying or the breaking up of the rocks takes place. So chemical weathering, the processes which are involved in chemical weathering are carbonation, oxidation, hydration and solution. So first we'll go with carbonation. So in this process of carbonation, the rainwater they mixed with carbon dioxide that is present in the air, and when they mix they form weak carbonic acid. Carbonic acid is formed, and this carbonic acid acts on the landform which have limestone and chalk. They are active on the limestone region, and they dissolve this carbonic acid. They will dissolve the limestone, and they will form various types of features there in the limestone region. So this is the process of carbonation. So the limestone is dissolved, and hence the rock is broken into pieces. So in the next one is oxidation. So the name itself is saying here oxidation. Oxidation here includes the gas oxygen. So oxygen, when they mixed up with the minerals present in the rock, so second process is oxidation. So in this process of oxidation, the oxygen which is present in the atmosphere, it combines with the mineral which is present in it combines with the minerals which is present in the rock. So especially the mineral with this process of oxidation, the rock which contains iron is affected the most. So when the iron containing rock, they come in contact with the oxygen and the water, they get rusted. So the rust, it makes the rock weaker, which will ultimately lead the rock to break into pieces. So this is the process of oxidation. Now next one is hydration. So here the word hydra means water. So in this, when the water they mix or they combine with the minerals which is present in the rock, they make the rock weak. So as a result, the rock they will crumble into pieces, or they will break into pieces. So next, the last one is the solution. So in this process of solution, the rocks which contains the minerals which will easily dissolve, those will get affected. So when the water they dissolve the minerals like the rock salt, like the limestone, the minerals will be taken away by this water, and only the other things will remain, so which will make the rock to break into pieces. So these four are the processes which are involved in the chemical weathering, and which will break the rock into pieces. So the next one is the biological weathering. So it also comes under the mechanical weathering or the physical weathering. So here the biological weathering means the rocks they are broken by the biological means. Bio means it is the living thing. So living things means under living things comes the plants, animals and human beings. So to some extent the plants, animals and human beings are also responsible for the breaking up of rocks. So biological weathering is also a part of mechanical or the physical weathering. So how the plant they break the rock, how the plant helps in the weathering of rocks. So the plants, the root of the plant, they will enter under the ground, or they will move under the ground in search of food and water. So while they are moving downward, they enter the cracks of the rock, so which will break the rock into pieces. So in this way plants help in the breaking of rock, and the animals, and especially the burrowing animals like the rabbits, like the rats, rodents, these are also responsible for breaking the rocks into pieces. And the human beings, human activities like the mining, like the farming, like the construction work, they also to some extent help in the breaking up of the rock. So this is all things, or these are all the agents which helps to break the rock, and all these things they come under the biological weathering. So now I'm going to do the most important topic, that is the landforms which is formed in the karst region or in the limestone region. So here first, doing the karst landforms in the karst region, we have to know what is carbonation. That I have already told. Carbonation is the process, or in carbonation the carbon dioxide which is present in the air, it mixes with the rainwater and it produces acid that is called carbonic acid. And when that carbonic acid it goes in the limestone region, then that acid, it will dissolve the limestone and it will form a beautiful landscape or many type of features in the limestone region, which is known as a karst topography, or it is also known as landform in karst region. So carbonation is the most important process which is responsible for the formation of different types of feature in the karst region. So here most of the landform in the karst region, they are formed by the solution. That means the solution by the solvent action of the rainwater or the carbonic acid, they will dissolve the limestone and they will form different types of features on the karst region. So first we'll go with the erosional features. First one is the lapis. So in the limestone region, in the limestone region, a very corrugated and a very rough ridges are found. A very sharp and a rough ridges are found like this. So they are. So that is known as the lapis. So lapis, these are the corrugated and a rough surface which is present in the limestone region, and these lapis, they have ridges, and they have these are the ridges, the pointed parts are the ridges, and these are called the clefts. So this is one of the feature that we see in the karst region or the limestone region. And there are numerous holes, numerous solution holes. Many holes are there on the karst region. So that is the lapis that comes under the erosional features. Now next one is the grikes or the clins. So grikes, what are these is due to the solution action of limestone. So I told you most of the feature in the limestone, it is formed by the solvent action of rainwater, by the process of solution, by the dissolving of the calcium carbonate. So when calcium carbonate, limestone, it contains calcium carbonate, and calcium carbonate, when it comes in contact with the carbonic acid, it turns into calcium bicarbonate. So that calcium bicarbonate can easily dissolve in water, and that will lead to the formation of different types of landforms. So second one is the grikes and the clins. So what is grike? So this is also formed by the solution, the solvent action of the water and in the limestone region. So here in this grike, a long furrow, a deep, long depression, a deep and a long depression is formed, that is known as grike, so which is separated by a rectangular block, so that this rectangular block of limestone is known as glins. So this type of grikes and glins, they are seen, or they are found in Madhya Pradesh in India. So another feature, another erosional feature in the which is found in the karst region or the limestone region is the sinkhole. So the name itself is saying holes. That means in the limestone region there are many holes on the surface of the limestone region. There are many holes, saucer shaped holes or a funnel shaped holes are there. So when the rain waters, they sink in these holes, so that is known as the sinkholes, or it is also known as swallow holes. So these are the holes which are present on the surface of the limestone region when the rain, and this is also formed by the solvent action of the rainwater in combination with carbon dioxide. So sinkhole is also known as swallow holes. It seems that it is swallowing the water, the rainwater which is flowing through this limestone region. Now next one is the dolines. So dolines, these are also the holes which are present in the limestone region, and they are the swallow holes, but they are much larger in comparison to the sinkhole. So all these are holes. Sinkhole is smaller in size, but dolines, it is bigger in size compared to the sinkhole. So the only difference is sinkhole is a smaller hole in the limestone region, and dolines, their size is larger compared to the sinkholes. Now the next one is the uvalas. So uvalas, these are also the holes or the depressions. These are also the holes or the depressions formed by the solvent action, formed by the process of solution and carbonation. So uvalas, these are formed by joining of many dolines. That means dolines, these are the bigger holes, and when many dolines, they join together, they form bigger holes, they are known as uvalas. So uvalas is also a hole in the limestone region, but they are much larger in size compared to dolines. So next one is the polges. So polges, these are, so when many uvalas, big holes, they join together, they form polges. So these are very, very big holes which are present in the limestone region. So all are holes, but the only difference is their size. These are the smaller ones. So when many sinkholes, they join together and make a bigger hole, they are known as dolines. And when many dolines, they join together and another big hole is formed, that is known as uvalas. And when many uvalas, they join together and they form a very, very big hole in the limestone region, then that is known as polges. So at the base or the floor of the uvalas or the polges, there are some hillocks or residual rocks are there, hard rocks or the resistant rocks are there. So this hillocks or the resistant rocks, these are known as humps. So these are some of the erosional features that we see in the karst region. Now next one is the ponors. So these ponors, these are the underground channels. Suppose this is a limestone region, a hole is formed there and there is a channel deep inside like this. So these channels, these are known as ponors. Ponors, these are the underground channels through which the streams they flow under the ground. Next one is the dry valley. So here in the dry valley, what happens is the streams and the rivers on the land surface. So suppose a river is flowing on the surface here. A river is flowing on the surface, but finally the stream here, there is a presence of a hole is there. So the stream, it will sink in this hole, it will enter the hole, and they will flow here under the ground as an underground river. So this is known as a dry valley. So it seems that the valley is dried up because all the water is entering underground through this hole. So that is called a dry valley. Now the last one is the cast window. So here the window says we can see through it. Through window we can see through it. So cast windows are those windows. Here what happens in the cast windows is this is also formed by the solvent action of the limestone, and here it creates underground channel like the ponors. In the karst topography, the underground channels are created like ponors here, and the surface water disappears. So here, if the river is flowing here on the surface, and when the underground channel has developed, the surface water, it will enter here, it will sink here through this hole, and as a result this underground water and this surface water, they will flow here under the ground as the subsurface river, and sometimes the roof of this cave. So the roof of this cave may collapse, and one can see through this river, or this river can be visible from here. So that is known as a cast window. So now we'll do the depositional features which are formed in the karst region or the karst topography. So first one is the terra rosa. So this terra rosa is not affected. Some of the things are not affected by the solvent action. They do not get dissolved because of the solvent action of the rainwater. So they remain there as a residue in the limestone region, and they are red in color because of the presence of iron oxide. So that is known as terra rosa, which is a depositional feature. Now the next one is the dripstone. So because here in the limestone region, because of the solvent action of the rain, the cracks or the joints, they develop in the limestone region. So through these cracks and the joints, the drops of water, they start to drip from these joints or the crack. So that is known as a dripstone. So it is nothing but it is a stone from where the drops of water, they continuously drip. Now the next one. Now the last one is the stalactite and stalagmite. So stalactite and stalagmite. So in the stalactite and stalagmite, what happens is there, so in the limestone region, big caves are found under the ground. Big caves are there they are present under the ground, that is formed by the underground water, by the solvent action of the rainwater, and by the process of carbonation. So in this one, through the cracks and the joints, the water enters. So water starts to drip from the roof. of the cave. They start to so the last depositional feature of the karst region or the karst topography is the stalactite and the stalagmite. So in the karst region, a huge caves are formed under the ground. So these caves, the roof of the caves has many joints and the cracks. So through these joints and the cracks, the water, it enters, it percolates, and it starts to drip drop by drop. So as the water starts to drop from these joints, partially the water is evaporated and a small amount of calcium carbonate remains there. So the calcium carbonate remains there, and in course of time it grows bigger in size, forming a pillar which is hanging from the roof of the cave. So in this way, many stalactites, they hang from the roof of the cave. So this pillars or this pillars or the which hang from the roof of the cave, that is known as stalactites. Now next one is the stalagmite. So same like the drop of the water which has reached the floor of the cave, it has also some amount of calcium carbonate, it gets deposited and it grows in size in course of time. So the this calcium carbonate which grows from the floor of the cave towards the roof, so this is known as stalagmite. So this is stalactite and stalagmite. Only the difference is stalagmite, it hangs from the roof, and stalagmite, it comes from the floor of the cave.
Hello students, today we are going to work on the first chapter of class 12's chemistry, and this chapter deals with the solution. But before we start this chapter, we are required to have some knowledge about a term called mole. Mole concept was there as a part of class 11 syllabus, so hope all of you know a little bit about moles, but still I wanted to tell you the meaning of 1 mole of a substance. Whenever we talk about 1 mole of anything, what we exactly mean is when we put 6.023 into 10 to the power 23 particles together. You know this number, 6.023 into 10 to the power 23. This number is called Avogadro's number, and it's a very large number because it has got 10 to the power 23, which is much larger than billion and trillions. If you have these many particles, what is the meaning of particles? If you have these many, let's say, atoms, then together the amount of that mass of that these many atoms together is called 1 mole atom. Similarly, if you have these many molecules, then we call that 1 mole molecule. So in order to have 1 mole of any substance, you've got to have 6.023 into 10 to the power 23 particles together. If you have these many electrons, we call 1 mole electron. If you have these many atoms, 1 mole atom. These many molecules, 1 mole molecule. But here in this chapter, we are basically interested in the molecules only, because most of the substances with which we prepare our solution exist in the form of molecules. So we'll deal with this 1 mole molecule. So what's the meaning of 1 mole molecule. 1 mole molecule means simply the mass of 6.023 into 10 to the power 23 molecules together. So if you have these many molecules, which is a big number, if you have all these molecules together, then the total amount is called 1 mole molecule. But there's another thing that we learned in class 11, and that is called gram molecular mass. So let me give you an example. You see, I've taken a molecule of water here. This is the molecular formula of water, H2O. So from this molecular formula, if you add the masses of all the atoms present here, that means 2 atoms of hydrogen and 1 atom of oxygen. You know what's the atomic mass of hydrogen? It is 1. So you're taking 2 atoms of hydrogen. One of them weighs 1, but there are 2 of them, so total is 2. And atomic mass of oxygen is 16. So I'll take only 16 because there's only 1 atom. So masses of all the atoms in this molecule together is going to be how much? 2 plus 16 is 18. So that's the mass of the molecule of water. It's known as molecular mass. From the molecular formula, by adding the masses of all the atoms, whatever we get is called molecular mass. Similarly, you can have some other molecules, like I'm taking molecule of carbon dioxide here, and this is the molecular formula of carbon dioxide. We can add the masses of carbon and oxygen atom present in its molecule and find its molecular mass. So carbon's mass is 12, oxygen's mass is 16, but there are 2 atoms, so the net mass is going to be 44. Okay, similarly, you can take another molecule. Let's say this is a molecule of a hydrocarbon called methane. So its molecular mass is going to be, carbon's mass is 12, hydrogen's mass is 1, but there are 4 atoms present in the molecule of methane. So the net mass is going to be 16. So this way, if you know the molecular formula of compound, we can add the masses of all the atoms present in the molecule to find its molecular mass. So everyone knows how to find the molecular mass. But if you take these substances, for example, I wanted to take water, but how much? Whatever is the molecular mass, same amount in grams. So molecular mass of water is 18, so I'll be taking 18 grams of water. Molecular mass of carbon dioxide is 44, so I'll be taking 44 grams of carbon dioxide. Molecular mass of methane is 16, so I'll be taking 16 grams of methane. So whatever is the molecular mass, same amount of the substance if you take, that mass is called 1 gram molecular mass. So how much is 1 gram molecular mass of any substance? Whatever is the molecular mass, same amount has to be taken in grams. So how much 1 gram molecular mass of water weighs? 18 grams. How much 1 gram molecular mass of carbon dioxide weighs? 44 grams. How much 1 gram molecular mass of methane weighs? 16 grams. Okay. But amazingly, these masses, that is gram molecular masses or molecular masses taken in grams, they all contain these many molecules. For example, 18 grams of water will have those many molecules, and 44 grams of carbon dioxide, which is 1 gram molecular mass of carbon dioxide, will have 44 grams of carbon dioxide will have these many molecules of carbon dioxide. 16 is the molecular mass of methane, so if you take 16 gram, it is known as 1 gram molecular mass, and 1 gram molecular mass, that is 16 grams of methane, is going to have those many molecules. Okay. So, you know, we can take these masses, that is molecular mass taken in gram, as 1 mole. You know why? Because all these masses, that is molecular mass taken in gram, has these many molecules, and if you have these many molecules, the mass is called 1 mole, isn't it? So is gram molecular mass, that is molecular mass taken in gram, 1 mole? Yes. Why? Because if you take molecular mass amount in gram, it will always have Avogadro number of molecules, and whatever has Avogadro number of molecule, it is known as 1 mole. Okay. So whenever we talk about any substance, how much is 1 mole of that substance? How much is 1 mole of water? It is 18 grams, because 1 mole means Avogadro number of molecule, which is present in the molecular mass taken in gram, that is 18 grams. How much is 1 mole of carbon dioxide? 44 grams. How much is 1 mole of methane? 16 grams. Okay. So if 18 grams of water has got 1 mole, then how much is 36 grams of water? If 18 gram is 1 mole, how much is 36 grams? Is it not 2 mole? Because 36 is double of 18, no? 18 gram molecular mass taken in gram is 1 mole of water. So double of 18, 36 gram is going to be 2 moles. 3 times this, 54 grams is going to be 3 moles. So just now we found that 54 grams of water, which is 3 times 18, it has 3 moles. Can we also find that number of moles? How many moles are there in 54 grams of water with some formula, instead of just finding the multiples of 18, like 18 gram is 1 mole and double of 18, 36 gram is 2 mole, and 3 times 18, 54 gram is 3 moles. Instead of finding the number of moles present in certain mass, can't we have a formula? And there's a formula like that. If you want to find the number of moles of any substance, when the mass of the substance is given, for example, they give you 54 grams of water and they ask you to find how many moles are there. So what you're supposed to do is simply take the mass of that substance out of which you're supposed to find the number of moles and divide that with the molecular mass of the same substance. So this is 54 grams of water. We're trying to find how many moles are there in it. So I'll divide the given mass of water in grams by the molecular mass of water itself, which is 18. And this divides 3 times. And that tells you that there are how many moles? 3 moles of water in 54 grams. So I want you to learn this. I want you to know this formula for finding the number of moles. You see how we found the number of moles of water in 54 grams of water? We divided the given mass of water in grams by the molecular mass of water itself. So number of moles given by, what are you supposed to do? Mass of a substance, whatever substance is being discussed, mass of a substance has to be, and that mass of a substance must be in what? It must be in grams, must be divided by its own molecular mass. So when you divide mass of any substance by its own molecular mass, the way we did it here, we get the number of moles. So this is a very important formula. I hope most of you know this formula, but even if you have missed it, I want you to keep a note of this formula, that every time you're trying to find the number of moles of any substance, how many moles are there. So what you're supposed to do is just take the mass of the substance and divide by its own molecular mass. Okay. So now we have a formula for finding the number of moles, which is going to be N, which stands for number of moles, is going to be mass of any substance divided by molecular mass. Okay. Now let's talk about solution. It's because this chapter deals with the solution. Let us try to understand what is a solution. A solution is nothing but a mixture. It's an impure substance. Because every time you prepare a solution, what you're supposed to do, you're supposed to at least take 2 substances and mix them together. Like for example, we mix water and salt. With only one component, it is not possible to prepare a solution. You have to have at least 2 substances, mixing together. So you can say that a solution is an impure substance. It's a mixture because it is prepared by mixing more than one substance. Most of the time our solutions are called binary solutions. Why binary? Because our solution will have 2 components, one solvent, another solute. Binary means something which has 2 components, solute and solvent. Okay. So in our solution, let's talk about a solution of salt in water. Let's say we'll be taking this sodium chloride. That's the common salt we use. So it's a solution of sodium chloride in water. You can prepare a solution of sodium chloride in water in so many ways. You can take 2 grams of sodium chloride and mix that in 1 liter of water. Or you can have another solution of same sodium chloride in water where you've taken, let's say, 10 grams of sodium chloride and added in 1 liter of water. Both these solutions are nothing but sodium chloride solution in water. You can have a third or fourth solution also like this, where you can add different amount of sodium chloride in water. So 2 grams dissolved in 1 liter, 10 grams dissolved in 1 liter, 15 grams dissolved in 1 liter. So you can have so many different solutions of same substance. So that means in a mixture, in a solution, you can have various amount of solute and solvent. The amount of solute and solvent can change, It is not necessary that every time sodium chloride dissolves in water that 2 gram has to dissolve in 1 liter. You can also have another solution of same sodium chloride where 10 gram dissolves in 1 liter. So that means in a solution the proportion or the amount of solute and solvent can change. And that's why whenever we talk about a solution, we must express this, that in my solution I've got this much of solute and that much of solvent. Unless you say that, if you only talk about a solution, it's quite meaningless. You know why? Because in your solution you can have any amount of solute up to its solubility limit, any amount of solute and any amount of solvent. So if you only say that I have a solution of sodium chloride in water, it doesn't make complete sense, because you must say that in your solution how much of sodium chloride is dissolved in what amount of water. And you know that expression, that way of saying that my solution has this much of solute and my solution has this much of solvent. What do you call that expression? That expression is called concentration of a solution. So what is the meaning of concentration of a solution? You see, so many times we have talked about concentration of my solution is so and so. What's the meaning? When you are saying concentration of my solution is so and so, you are trying to say that in my solution how much of solute and how much of solvent is present. Okay. So that means we can measure or express the amount of solute or amount of solvent in a solution. But all these measurements or expression requires some kind of units, you know. So to express the concentration of a solution, to say that my solution has so much of solute and so much of solvent, there must be ways, there must be units, you know. So we're going to see few such expressions of concentration of a solution, few ways of telling that my solution has so much of solute and so much of solvent. That means we'll see some units of concentration of a solution. Okay. One of the first way we can express the concentration of a solution is called mole fraction. You see, there are so many ways we can express, there are so many ways in which we can express the concentration of a solution. You may have heard of those different terms, like we can do it in percent strength, we can do it in grams per liter, we can do it in mole fraction, we can do it in molarity, we can do it in molality, and we can do it in normality. There are so many ways, but because there is a constraint of time, so whatever is required absolutely in this chapter, we are only going to discuss those concentration terms. So the most important out here is going to be mole fraction. So what is mole fraction of a solution? It is a way of saying that my solution has so much of solute and so much of solvent, because you must say that. Unless you say that, your expression will not have complete meaning. So mole fraction is a concentration term. What is the meaning of mole fraction? Mole fraction can be defined as the fraction of number of moles of a component, fraction of number of moles of a component in a solution to the total number of moles of this, to the total number of moles of all the components, you can say all the components in a solution. Usually our solutions will have two components, solute and solvent, but you know that it's also possible to mix 3 things to prepare a solution, or mix 4 things also, but such solution is going to be very complicated, so we're not going to deal with such a solution. We'll only have 2 components, solute and solvent. So let's say we have a solution or a mixture like that, where 2 substances are being mixed, A and B. A could be solute, okay, and B could be solvent. Or it doesn't matter also which one, solute and solvent. We can only say that there's a mixture or a solution where A and B are mixed together. So it's a binary mixture or a solution. While mixing A, or while taking A and while taking B to prepare this solution, let's say the number of moles of A is Na. Do you know how to find the number of moles of A? What are you supposed to do? I think you remember the formula which we earlier discussed. How do you find the number of moles of anything? When you divide the mass of A that you take with the molecular mass of A, you get the number of moles of A. In the same manner, right in the beginning while preparing this solution, you can also find out how many moles of B you are taking. Let's say you have taken NB moles of B. Okay, so what is the total number of moles of all the components here? You've got NA moles of A and NB moles of B. So the total number of moles of the solution is going to be Na plus NB. Now what is the mole fraction of A? In this mixture, if you are trying to express that in my solution or in my mixture, what amount of A is there, you can do it in a term called mole fraction. And mole fraction of A is going to be the fraction of number of moles of A. So what is the number of moles of A you have taken? Na over the total number of moles of all the components. So you've got only two components there. The total number of moles of A and B taken together is going to be Na plus Nb. Okay. So when you divide the number of moles of any component in a mixture by the total number of moles of all the component, the fraction you get is called the mole fraction of that component. Similarly, how do you find the mole fraction of B? When you divide the number of moles of B, this time Nb, by the total number of moles of all the components, that is Na plus Nb, that fraction of number of moles of B over the total number of moles of all the component is going to be known as the mole fraction of B. So what is this mole fraction of A represents? It represents the amount or the proportion of A in this mixture. When A is in large amount, that means Na is going to be big. When A is in large amount, Na, that is number of moles of A, is going to be big, and naturally the mole fraction of A also is going to be big. So higher the mole fraction of A, what we understand that the amount of A in the mixture is large. If you have a mixture where the mole fraction of B is very small, which means the number of moles of B is small, that means there's very little amount of B present in the mixture. So expression of mole fraction therefore represents the proportion of A and proportion of B in the mixture. So this way you can express the concentration of a solution or a mixture in terms of mole fraction of components. Remember, fraction is always calculated out of 1. Like percentage is always calculated out of 100, fraction is always calculated out of 1. So what should be the sum of mole fractions of all the components? You've got only two components here, so if you add the mole fraction of all the components here in this mixture, the total must be 1. Like total of all the percentages in a mixture, let's say you've got two things, A and B mixed together. If A is 25%, the B must be 75%, because total of all the percentages of A and B together must be 100, because percentage is always calculated out of 100. Similarly, the fractions are always calculated out of 1. So the net sum of mole fractions of all the component must be 1. And we can prove that if you add these two mole fractions, then the net sum is going to be 1. Let's see. What is XA? Isn't it Na by Na plus Nb? It is. And what is XB? That is mole fraction of B. Isn't it Nb divided by Na plus Nb? So these are the mole fractions of A and B. So let me find the LCM of denominator, which is going to be Na plus Nb, because it's same both sides, and then this cancels and divides, so there will be Na left and Nb there. So both these cancels and the sum is going to be 1. So I told you that the mole fraction, the sum of mole fractions of all the component in a mixture must be 1. The way the sum of all the percentages is always equals to 100. Okay. So this is the first expression of concentration, that you can express the concentration of your mixture or a solution in terms of mole fraction of solute and mole fraction of solvent. Okay. In this chapter, all the properties of solute are given this suffix 2. Whatever belongs to solute is marked as 2. Like weight of the solute will be written as W2. Molecular weight of the solute will be written as M2. Similarly, the mole fraction of the solute will be given as X2. That's the some kind of rule here in this chapter. So all the properties of all the variables of solute are marked with 2, and all the variables or properties of solvent is marked as 1. So if you follow that convention, it's going to be easier. After completing the discussion on the mole fraction. Now let's talk about the another concentration term that is also important in this chapter. And that concentration term is called molarity. So what is molarity? Molarity is also a way of telling that my solution has so much of solute and so much of solvent. So it's an expression of concentration. So what is molarity? By definition, molarity is the number of moles. So you all know how to find the number of moles. To find number of moles of anything, you have to divide its mass by its own molecular mass. So number of moles of solute, number of moles of solute dissolved in 1 liter solution. Remember, it's not solvent, it's 1 liter solution. 1 liter solution means what? Means this 1 liter will have both solute and solvent together. It's not 1 liter solvent, it's 1 liter solution. For example, okay, let me take this acid. All of you know this acid with the formula H2SO4 is called sulfuric acid. So that's its molecular formula. So let me add the masses of all the atoms present here. There's one hydrogen. So you see what I'm doing? I'm trying to find the molecular mass. So hydrogen is there, its mass is 1, there are 2 of them present. Sulfur's atomic mass is 32, let me tell you. Oxygen's mass, you know, it's 16, but there are 4 atoms. So if you add the masses of all the atoms present in the molecule of sulfuric acid, the net mass is going to be 98. So that's the molecular mass of sulfuric acid. Okay, 98 is the molecular mass of sulfuric acid. And you know that whatever is the molecular mass, if you take that in grams, it's known as 1 gram molecular mass and is also known as 1 mole because it contains Avogadro number of molecule. So 1 mole of sulfuric acid is nothing but its molecular mass taken in grams. So remember, if you have 98 grams of sulfuric acid, it's going to be 1 mole. Okay. So I have over here a measuring cylinder which is used for measuring volumes of liquids, you know. So there's a measuring cylinder and there are markings here to find the volume of liquids poured in it. So let's say this is a mark for half liter, 500 ml, and this is the mark for 1 liter. So what I'll do is I'll be taking 98 grams of sulfuric acid. Why 98 only? Because I know that its molecular mass is 98. So if I happen to take 98 grams, whatever is molecular mass, that amount in grams, I know it's going to be 1 mole. Why I'm so concerned about the moles? Because molarity is nothing but the number of moles of solute dissolved in 1 liter solution. So I require number of moles to find the molarity or to express the concentration of my solution in molarity. And that's why intentionally I have taken sulfuric acid, that also how much? 1 mole. Okay, that is molecular mass taken in grams. So here I have 98 grams of sulfuric acid. That is 1 mole of sulfuric acid. Now, after adding sulfuric acid, I'll start adding water to it. So I'll add water now. So that means now water and sulfuric acid is getting mixed. So it's a solution of sulfuric acid and water. So if you keep on adding water, the volume will come up to this. After that, I'll stop adding water now because the volume has reached 1 liter. Is this 1 liter of water? No, it is not 1 liter of water because before adding water, I have already added sulfuric acid. So it is 1 liter of the solution. Okay, it's a 1 liter of a solution because it has got water and sulfuric acid both present. So I have 1 liter of solution. And in this 1 liter of solution, how many moles of sulfuric acid is present? Because sulfuric acid is solute here. So how many moles of solute or sulfuric acid is there? 1 mole because I added 98 grams, that is molecular mass taken in grams. So in 1 liter of the solution, I have got 1 mole of sulfuric acid. And whatever number of moles of the solute is present in 1 liter solution, that is going to be the concentration of this solution in molarity. So molarity is going to be 1. It's called 1 molar. Why is it 1 molar? Because in 1 liter solution, I have got 1 mole of solute, that is 98 grams of sulfuric acid. So that's the meaning of molarity. Molarity is the number of moles, whatever number of 10 moles, 5 moles, whatever number of moles of solute you've got in 1 liter solution, that's known as molarity. Okay. For example, if you've got 10 moles of sulfuric acid here in 1 liter solution, the molarity or the concentration of the solution is going to be 10 molar. Okay, so this is how one can express the concentration of a solution in this next term called molarity. But the problem with the molarity is that every time you try to express the concentration of your solution in molarity, you have to have 1 liter solution. If you don't have 1 liter solution, then you will not know how many moles are present in 1 liter. But it's not always possible to prepare 1 liter solution. What if you don't have 1 liter solution? You've got only 100 milliliter of a solution. You've got only 250 milliliter of a solution. So isn't it possible to express the concentration of that little bit of solution also in molarity? There should be a way out, because as per the definition, whatever is the number of moles present in 1 liter, then only that number of moles called molarity. But if you don't have 1 liter, then you get into trouble, because then you'll not know how many moles are there in 1 liter, then you'll not be able to express the concentration of the solution in molarity. So what is the way out? The way out is to have a formula, to have a relation with which we can find the concentration of any solution having any volume, need not be 1 liter, in terms of molarity. So that's what we'll try to do. Though this derivation is not part of our syllabus, we are not required to derive, but still you should understand how do we get this formula for finding the concentration of a solution in molarity. So how do I do that? I'll assume that I have V liter of solution. I've got V liter of solution. By taking V liter, I have broken that constraint of 1 liter. I need not have 1 liter. I can have any amount. That's why I've taken V liter. This V could be half liter, 1/10 of a liter, or 20 liter. V can represent any volume of the solution. So I've got V liter of the solution. And that V liter of the solution dissolves, let's say, W grams of solute. Okay. So I've got V liter solution, any volume of the solution, and has that many grams of solute dissolved in it. So that's the mass of the solute dissolved in V liter solution. But you know that the mass of the solute is not going to give me molarity. Molarity is not about the mass of the solute. Molarity is all about the number of moles. So if I just put the mass there, it's not going to give me concentration in molarity. So I need to somehow convert this into number of moles, because molarity is the number of moles of solute. So how do you convert this into number of moles? What you can do is you can simply divide this mass with the molecular mass, isn't it, of the solute. You know the mass of the solute you've added, W grams. So what you do is divide that mass you've added in the solution with the molecular mass of the same solute, and that mass by molecular mass is going to give you what? Isn't this number of moles? Yeah, that's how we find the number of moles, by dividing the mass of any entity with its molecular mass. So this is going to be the number of moles of solute. So I've got V liter of the solution. Within that, W by M moles of solute is there. Mass by molecular mass, which is number of moles of solute, is there. So is this number of moles of solute the molarity of this solution? No, because this is the number of moles of solute present in V liter. But number of moles of solute present in 1 liter is going to be molarity. This is not 1 liter, this is V liter. So if V liter has that many moles, can't you find 1 liter will have how many moles? Because it's going to be a simple unitary method problem. So V liter has that many moles. 1 liter will have how many moles? So it's going to be W by M divided by V. Yeah, this V goes there and divides. So that's the number of moles of solute dissolved in 1 liter, isn't it? And whatever is the number of moles of solute dissolved in 1 liter, according to definition, that is going to be the molarity of this solution, or the concentration of this solution in molarity. So I've got these many moles in 1 liter, and that number of moles in 1 liter is molarity. So what's the formula molarity? We saw formula molarity is W by M by V. So let's see what is this W. W is the mass of the solute dissolved, but since mass is not going to give me molarity, so I have to divide the mass of the solute by the molecular mass of the solute, and that gives me the number of moles of the solute. So number of moles again is divided by the volume of the solution in liters, because number of moles divided by the volume of the solution in liter gives you the number of moles in 1 liter, and that's why it is known as molarity. So why in the expression of molarity, why in the formula molarity, there is mass divided by molecular mass, to get the number of moles, because molarity is number of moles. And why the number of moles? Again divided by the volume of the solution in liters, because we have to supposed to get the number of moles present in 1 liter. That's why this volume goes and divides. So that's the formula of molarity. Sometimes the formula of molarity is also modified and written as N by V. Is this right? This is right. Why? Because mass by molecular mass, can't you write that as number of moles? So W by M I'm writing as N, number of moles, and then divided by V. So that's how molarity is found. Okay. Now, since two of the expressions of concentrations are over, mole fraction and molarity, we'll head for the third one. And this expression, the third way of expressing concentration, is called molality. It's not molarity, it's molality. So what's the meaning of molality? Molality is also a way of saying that my solution has so much of solute and so much of solvent. So it's an expression of concentration. So molality is what? Molality is also number of moles of solute. Exactly like molarity, which is number of moles of solute. Molality is number of moles of solute dissolved in 1 kg, or 1 kg means how many grams? 1000 grams of solvent. So the difference here is molarity is the number of moles of solute dissolved in 1 liter solution. We had 1 liter solution containing both solute and solvent. But here molality is the number of moles of solute dissolved not in 1 liter solution but only 1 kg solvent, okay, or 1000 grams of solvent. So what's the meaning of that? Let me explain the meaning of that. You see, right in the beginning you are supposed to take 1 kg solvent. So I have taken 1 kg water, that is 1000 grams of water. So it's not 1 kg solution or 1 liter solution, only 1 liter solvent. So directly 1000 grams of water I have taken. And to this I'll add 98 grams of sulfuric acid. You already know from our previous discussion that 98 is the molecular mass of sulfuric acid. So the molecular mass taken in gram is going to be 1 mole. So I've taken 1 mole of sulfuric acid and I've dissolved that in 1000 grams of water directly. Okay. So when you add that 98 grams, the mass is going to increase. It's going to be more than 1000, because 1000 plus 98 is going to be 1098 grams. Okay. So I have added 1 mole of solute in 1 kg solvent. And whatever number of moles of solute is there in 1 kg solvent, that's known as molality. So the molality here is 1. I can write this as 1 molal. You see, molarity is expressed as capital M and molality small m. Okay. So that's how the concentration of a solution is expressed in molality. You see, if you add 2 moles of this in 1 kg, then the molality is going to be 2, because molality is the number of moles of solute in 1 kg solvent. Okay. So if you add 1 mole of sulfuric acid, molality is going to be 1. If you add 10 moles of sulfuric acid in 1 kg solvent, the molality is going to be 10. Again, there is a problem here, exactly like molarity. The problem is that you have to have a solution prepared by dissolving certain number of moles of solute in 1 kg solvent. It's not always possible to take only 1 kg solvent, you know. Sometimes if you are preparing a little bit of solution in a test tube or in a volumetric flask, so it's not possible to always take 1 kg of solvent. So what if you have prepared a solution which does not have 1 kg of solvent dissolved in it, you know? Then how do you calculate the concentration of your solution in molality? So there must be a formula exactly like molarity. Okay. So we're trying to find the formula for molality. The formula is going to be like this. First look at it. See, I've got W1 grams of solvent. Earlier I started, in the case of molarity, I started with V1 liters, because there the volume of the solution was required. Here there's no volume anywhere. You see, number of moles in 1 kg, so there are only masses. So I've taken W1 grams of solvent. By taking W1 grams of solvent, I'm breaking that barrier, that constraint of 1 kg. So I'm saying I don't have 1 kg, I don't have 1000 grams of solvent, I have got W1 grams of solvent, which could be 10 grams, 20 grams, 100 grams, 1000 grams, any amount. So I've got W1 grams of solvent, and let's say that dissolves W2 grams of solute. So W1 grams of solvent, I told you in the beginning, all the properties of solvent are marked as 1. There will be 1 suffix given to all the properties of solvent, and all the properties of solute are marked as 2. So I've got W1 grams of solvent dissolving W2 grams of solute. But soon I realized that the mass of the solute, W2 grams, is not going to give me molality, because molality is not the mass, molality is the number of moles of solute. So this mass of solute, can you convert into number of moles? Yes, you already know how. You just have to divide this mass of solute by the molecular mass of the solute, isn't it? Then that gives the moles of solute. So you understand why we are dividing the mass of the solute by the molecular mass, because that gives the number of moles of the solute, and that's what we need, number of moles of solute, to express the concentration in molality. So is this number of moles of solute dissolved in W1 grams of solvent molality? No. According to this, number of moles dissolved in 1 kg is molality, but this number of moles dissolved in not in 1 kg but in W1 grams, isn't it? So this is not going to give me molality. So what I'll do is, if W1 gram has that many moles, then 1000 gram will have how many moles? If you have 1000 grams, I can simply find using unitary method. So W1 has that many moles, 1000 will have how many moles? What do I do there? I take this W1 the other side and divide, and then 1000 goes and multiplies, isn't it? That's how unitary method is carried out. W1 divides there, 1000 multiplies. So I have the number of moles of solute here that is dissolved in 1000 grams of solvent, and number of moles of solute dissolved in 1000 grams of solvent is molality. So that's the molality. Okay, so what's the formula of molality now? So molality is going to be W2 by M2 divided by W1 and multiplied by 1000. So let us analyze this formula of molality to understand why the formula is like this. Why there is W2 by M2? Because W2 mass of the solute, when you divide by the molecular mass of the solute, you get number of moles of solute. And that number of moles of solute, when divided by the mass of the solvent and multiply by the 1000, you get the number of moles present dissolved in 1000 grams. And number of moles dissolved in 1000 grams is called molality. So each and every component of this formula has some meaning, you know. Why mass of the solute is divided by molecular mass to get the number of moles, because number of moles of solute is required as per the definition. And why the number of moles of solute is again divided by the mass of the solvent and multiplied by the 1000, because when you divide that number of moles with the mass of the solvent and multiply with 1000, you get the number of moles dissolved in 1000 grams. That's known as molality. Okay. So this way we have another concentration term introduced here, is called molality. But in exam, they can ask you this. In fact, I remember this kind of question had come on once in our exam. The question will be, if you already have molarity, which you calculate by dividing the mass of the solute by molecular mass divided by the volume of the solution, why do we need molality? What's the need of having molality? You can always express the concentration of your solution in molarity. Then why to have another unit or another expression of concentration? The reason why molality is here is molarity depends on the volume of the solution. There is this volume of the solution here. And volume of solution or liquids tend to expand or contract with the changes in temperature. When the temperature rises, volume starts expanding. So volume increases. And when the temperature decreases, volume contracts. So that's why when temperatures are changing, molarity is going to get affected. What is the meaning of that? If you calculate the concentration of your solution in molarity, out here in Darjeeling, where the temperature is low now, and take that solution somewhere else where the temperature is high, then the molarity is not going to remain same. You've got to recalculate the molarity there, because molarity changes with the change in temperature. Why? Because with the change in temperature, the volume expands or contracts. So when the volume of the solution itself changes, the molarity also changes. So that's why molarity is sensitive to changes in temperature and pressure. So we needed a concentration term which is not affected by changes in temperature and pressure. And that's why we have molality. Look at the formula molality. We've got only masses everywhere. Mass of the solute, mass of the solvent, molecular mass of the solute, and multiplied by 1000. So there is no volume involved anywhere. So because of that, whether you calculate the molarity of the solution here in Darjeeling or in any other place where the temperatures are different, this amount, that is the concentration calculated in molality, is not going to change with the change in temperature. It remains same. And that's why molality, you can say, is independent of changes in temperature, is not affected by the changes in temperature. And that's why it's so special way of expressing the concentration of a solution. So that way we have finished discussing different aspects of concentration terms, like different ways of expressing concentration. Now we can start this chapter properly.
Hello everyone, I am Prawesh Gurung, an assistant teacher from Turnbull H.S. Once again, I am back to our online class. So today, we will be learning costing, and under this costing, we have a chapter called labor. Right? तिमीहरुको नयाँ chapter. So now, तिमीहरुलाई के थाहा छ भन्दाखेरि different एउटा subject नै छ costing. So under this costing we have a chapter called labor. यो labor चाहिँ तिमीहरुको exams मा 40 marks को आउँछ. So अब हामी के गरौँ भन्दाखेरि let's start with the chapter. First अब हामी बुझौँ what is labor, कतिवटा टाइपको लेबरहरु हुन्छ, हामीले कसरी क्लासिफाई गरेको छ है. So now अब हामी लेबरलाई बुझ्नु हो भने लेबर चाहिँ अब एउटा इम्पोर्टेन्ट फ्याक्टर हामी मान्छ कस्टिङमा पनि, जस्तो इकोनोमिक्समा मानिरहेको छ. इकोनोमिक्समा पनि कस्ट अफ प्रोडक्सनमा एउटा लेबरलाई हामीले एउटा फ्याक्टर नै राखेको छ. त्यस्तै प्रकारले अब हामीले कस्टिङ गर्दा पनि हामीले के याद गर्छौं भन्दाखेरि मटेरियल, लेबर र ओभरहेड है. अच्छा, मटेरियल त त्यसै पनि तिमीहरुको यो सिलेबसमा डिस्कस भइसकेको नै छ. ओभरहेड पनि तिमीहरुको छैन. अब गर्नुपर्ने खाली लेबर रहेछ है. अच्छा, अब यो लेबर चाहिँ के हो कसो हो भन्दा अब यहाँ हेरौँ. लेबरलाई चाहिँ हामीले कस्तो प्रकारले हेर्छ कस्टिङमा भन्दाखेरि लेबरलाई दुई प्रकारले छुटाइदिएको छ. There are two types of labor. One is direct labor and another one is indirect labor. अच्छा, डाइरेक्ट र इनडाइरेक्ट लेबरमा के डिफरेन्स छ भन्दाखेरि कुनै पनि प्रोडक्सन बनाउँदाखेरि त्यो लेबर चाहिँ डाइरेक्टली इन्भल्भ हुनुपर्छ त्यो प्रोडक्सन्सको लागि है. त्यो जुन चाहिँ अब तिमीहरुकोमा र मटेरियल आएको छ त्यो र मटेरियलमा चाहिँ डाइरेक्टली इन्भल्भ भएको हुनुपर्छ, सो दैट उले चाहिँ त्यो प्रोडक्सन दिनु पर्यो. जस्तै कि यो मार्कर बनाउनुको लागि हो भने यो मार्कर बनाउँदाखेरि जुन चाहिँ अब लेबर त्यसमा अब लागिरहेको छ है, यसलाई जसले म्यानुफ्याक्चर गर्छ त्यस्तो खालको लेबरलाई चाहिँ हामीले डाइरेक्ट लेबर भन्छ. इनडाइरेक्ट चाहिँ कस्तो भन्छ, यो अब मार्कर बनाउने नै अब फ्याक्ट्रीमा गयो भने सुपरभाइजर हुनसक्छ, त्यसमा अब गेटकिपरहरू हुनसक्छ है. कोही चाहिँ अब कस्तो हुन्छ भन्दाखेरि त्यसमा त्यो क्लिनिङ गर्नेहरू मान्छेहरू है. त्यस्तो खालको लेबरलाई चाहिँ हामी के मान्छ भन्दाखेरि इनडाइरेक्ट लेबर. ठिक छ. अच्छा, डाइरेक्ट लेबर र इनडाइरेक्ट लेबर त भयो. अब यहाँ के हुन्छ भन्दाखेरि अब एउटा चाहिँ याद गर्नुपर्ने अर्को लेबरमा चाहिँ अब फेरि हामीले के याद गर्नुपर्छ भन्दाखेरि टाइम किपिङ र टाइम बुकिङ. फेरि यो के हो टाइम किपिङ र टाइम बुकिङ भन्दाखेरि टाइम किपिङ भनेको चाहिँ कस्तो भन्दाखेरि जब फ्याक्ट्रीमा अब लेबरहरू जब एन्टर हुँदाखेरिको उनीहरूको जब रेकर्ड राख्छ है, उनीहरूको एन्ट्री र एक्जिट जसले याद गर्छ, जहाँ चाहिँ रेकर्ड राख्छ त्यसलाई चाहिँ हामीले भन्छ टाइम किपिङ. अर्को टाइम बुकिङमा चाहिँ के हुन्छ, जब उनीहरू एन्टर भइसकेको बादमा उनीहरूको दिनभरिको जुन चाहिँ त्यो उनीहरूको दिनभरिको जर्नल उनीहरूले मेन्टेन गर्छ. त्यसमा को वर्करले कति प्रोडक्सन उसले अब मतलब कति युनिट प्रड्युस गर्यो, कति युनिट उसले बनाउन सक्यो है, यस्तो जति पनि रेकर्डहरू राख्छ त्यो सबै केमा राख्छ, टाइम बुकिङमा राख्छ. ठिक छ. अच्छा अब हामीले यो लेबर डाइरेक्ट इन्डाइरेक्ट बुझ्यो, टाइम किपिङ र टाइम बुकिङ बुझ्यो। अब अर्को के बुझौँ भन्दाखेरि आइडियल टाइम। अच्छा आइडियल टाइम भनेको चाहिँ के हो भन्दाखेरि जहाँ चाहिँ लेबरहरूलाई पेमेन्ट हुन्छ तर त्यो कस्ता खालको पेमेन्ट हुन्छ भन्दाखेरि त्यो टाइममा चाहिँ उनीहरूले केही प्रड्युस नै गर्दैन है। जब चाहिँ युनिट प्रड्युसै नगर्दाखेरि पनि उनीहरूको त्यो टाइममा चाहिँ उनीहरूको पेमेन्ट हुँदैछ भने त्यस्तोलाई चाहिँ हामीले आइडियल टाइम भन्छ। आइडियल टाइम पनि दुईवटा छ, एउटा नर्मल, अर्को अबनर्मल। नर्मल र अबनर्मल आइडियल टाइम भनेको चाहिँ फेरि के रहेछ भन्दाखेरि नर्मलमा चाहिँ कस्ता खालके हुन्छ भन्दाखेरि जुन चाहिँ हामीले अभोइड गर्नै सक्दैन नर्मल टाइम है। अब त्यो टाइम स्पेन्ड हुन्छै हुन्छ। जस्तो कि मैले अघि के भने भन्दाखेरि गेटमा जब लेबरहरू एन्टर हुन्छ, लेबर एन्टर हुँदाखेरि त्यो गेटदेखिको लिएर आफ्नो डिपार्टमेन्टसम्म पुग्दाखेरि 5 मिनट्सको डिस्टेन्स हुनसक्छ, वकिङ डिस्टेन्स है। त्यो टाइम जब स्पेन्ड गर्छ, यो टाइम स्पेन्ड गरेकोलाई त हामीले त यसलाई त अभोइड गर्नु सक्दैन नि त है। यस्तो खालके अब लन्च ब्रेक हुनसक्छ, टी ब्रेकहरू हुनसक्छ, त्यस्तोलाई चाहिँ हामीले केमा कन्सिडर गर्छौँ भन्दाखेरि नर्मल आइडियल टाइम। अबनर्मल आइडियल टाइम चाहिँ जुन चाहिँ अब हामीले त्यसलाई चाहिँ अभोइड गर्नु सक्छ, अभोइड गर्नु नसक्दा पनि यो अबनर्मल चाहिँ तिम्रो अकर हुन्छै हुन्छ। जस्तो कि अबनर्मलमा चाहिँ के हुन्छ भन्दाखेरि ब्रेकिङ डाउन अफ मसिन है, पावर फेलियर, यस्तो खालके कुराहरूलाई चाहिँ अब हामीले यसको लागि ब्याकअप त राख्न सक्छ नि है। यस्तो खालके आइडियल टाइमलाई चाहिँ हामीले अबनर्मल आइडियल टाइम भनेर हामीले मानेका छ। ठिक छ। अब यो लेबरमा पेमेन्ट सिस्टम चाहिँ कस्तो प्रकारले हुन्छ र कहाँबाट हुन्छ भन्दाखेरि त्यसको पनि अलिकति तिमीहरूलाई बुझाइदिइहाल्छु। अच्छा एउटा फ्याक्ट्रीमा गयो भने के हुन्छ भन्दाखेरि तिमीहरूकोमा पेरोल डिपार्टमेन्ट हुन्छ है। यो पेरोल डिपार्टमेन्टलाई चाहिँ इन्फर्म गर्छ, कसले इन्फर्म गर्छ भन्दाखेरि टाइम किपिङ डिपार्टमेन्टले। टाइम किपिङ डिपार्टमेन्टले चाहिँ पेरोल डिपार्टमेन्टलाई इन्फर्म गर्छ कि को वर्कर चाहिँ कति बजी आयो र कुन चाहिँ वर्कर चाहिँ आज प्रेजेन्ट छ कि छैन, उनीहरूको अटेन्डेन्स चाहिँ टाइम किपिङ डिपार्टमेन्टले पठाउँछ। त्यस्तै एउटा डिपार्टमेन्ट हुन्छ फाइनान्स डिपार्टमेन्ट। फाइनान्स डिपार्टमेन्टले फेरि पेरोल डिपार्टमेन्टलाई के गर्छ भन्दाखेरि उनीहरूको पे स्केल चाहिँ कस्तो प्रकारले बनाएको छ, कुन चाहिँ वर्करलाई चाहिँ कति पेमेन्ट गर्छ र वेज रेट के हो भने चाहिँ पेरोल डिपार्टमेन्टलाई चाहिँ उनीहरूले पठाउँछ है। अच्छा पेरोल डिपार्टमेन्टले त्यसपछि चाहिँ के गर्छ, उनीहरूको टाइम किपिङको इन्फर्मेसन पनि पाउँछ, को कति दिन एब्सेन्ट छ, को कति दिन प्रेजेन्ट छ र को कति डिले भएको छ है। उनीहरूको त्यो फ्याक्ट्रीमा आउँदाखेरि एक्जिटको छिटो को ढिलो हुँदैछ, ओभर टाइम कसो के छ, यो सबै टाइम किपिङबाटै थाहा हुन्छ। र उनीहरूको पेमेन्ट चाहिँ त्यो लेबरहरूको कति पाउने त्यो फाइनेन्स डिपार्टमेन्टकोबाट उनीहरूले के पाउँछ, इन्फर्मेसन पाउँछ है। त्यो इन्फर्मेसन पाइसकेर उसले कसलाई दिन्छ भन्दाखेरि कस्टिङ डिपार्टमेन्टलाई दिन्छ। कस्टिङ डिपार्टमेन्टले चाहिँ यो इन्फर्मेसन पाइसकेको बादमा चाहिँ उसले चाहिँ लेबरलाई एट लास्ट पेमेन्ट गर्छ। ठिक छ। सो लेबरलाई पेमेन्ट गर्नुको लागि चाहिँ हामीलाई यो सबै डिपार्टमेन्ट हुनु जरुरी छ एउटा फ्याक्ट्रीमा। अच्छा अब यो त अब हामीले बुझ्नु त बुझ्यो अब लेबरमा पेमेन्ट कस्तो प्रकारले हुन्छ है, कुन कुन डिपार्टमेन्ट इन्भल्भ हुँदो रहेछ। तर अब हामी बुझौँ कि यो वेज पेमेन्ट चाहिँ कस्तो प्रकारले चाहिँ अब हामीले गर्नुपर्ने। सो वाट आर द डिफरेन्ट मेथड अफ वेज पेमेन्ट। डिफरेन्ट मेथड अफ वेज पेमेन्ट चाहिँ के छ भन्दाखेरि एउटा छ टाइम रेट, एउटा छ पिस रेट, अर्को छ बोनस प्रिमियम प्लान। पिस रेट जुन चाहिँ छ पिस रेटमा पनि दुईवटा छ एउटा छ स्ट्रेट पिस रेट अर्को छ डिफरेन्शियल पिस रेट अच्छा अब यो बोनस प्रिमियममा पनि दुईवटा छ एउटा हेल्से एउटा रोवन है अच्छा डिफरेन्शियल पिस रेट पनि फेरि दुईटा क्याटेगराइज गरेको छ एउटा टेलर्स एउटा मेरिक्स यो सिस्टम चाहिँ के हो भन्दाखेरि अब फ्याक्ट्रीमा उनीहरूले यो मेथड चाहिँ युज गर्छ कि वेजेस पेमेन्ट गर्ने बेलामा लेबरहरूलाई है टाइम रेट भनेको सजिलो नै छ के हो भन्दाखेरि टाइमको हिसाबले तिमीले पैसा पाउँछौ को वर्करले कति घण्टा काम गर्यो लेट्स से पर आवरको वेज छ अरे ₹20 पर आवरको पर आवर कोही वर्करले 5 आवर्स काम गर्यो 5 × 20 त्यसमा कति ₹100 भइगयो यो त है सिम्पल छ यो टाइम रेटमा त्यस्तो केही प्रब्लम हुँदैन पिस रेटमा पनि जब हामी आउँछ यो स्ट्रेट पिस रेट पनि सजिलो नै हुन्छ स्ट्रेट पिस रेटमा के हुन्छ भन्दाखेरि जति तिमीले युनिट प्रड्युस गर्छौ है मानिलियौँ एउटा वर्करले 100 वटा युनिट प्रड्युस गरे अरे अन्त लेट्स से 1 युनिटको चाहिँ पाउँछ अरे ₹5 त्यो भने के गर्छ हामीले 100 युनिट्स इन्टु ₹5 त्यसमा 500 उसको पेमेन्ट हुन्छ यो त सजिलो नै छ हाम्रो टाइम रेट स्ट्रेट पिस रेटमा तर जब डिफरेन्शियल पिस रेट आउँछ है डिफरेन्शियल पिस रेटमा चाहिँ अलिकति हामीलाई चाहिँ के गरेको छ भन्दा अलिकति त्यसलाई मोडिफिकेसन छ डिफरेन्शियल पिस रेट सिस्टममा चाहिँ त्यो मोडिफिकेसन चाहिँ कहाँ आउँछ भन्दाखेरि यो चाहिँ अलिकति अब यसमा चाहिँ उनीहरूले मोटिभेट गर्नुपर्छ है कस्तो प्रकारले गरेको छ भन्दा पहिला हामी बुझौँ टेलर्सले चाहिँ के भनेको छ त्यसपछि हामी मेरिक्समा बुझौँ है त अच्छा टेलरले चाहिँ के भन्छ भन्दाखेरि वर्करहरू त्यसमा दुई प्रकारले छुट्याइदिएको छ एउटा इफिसियन्ट एउटा इनइफिसियन्ट हुन्छ ठीक छ एउटा इफिसियन्ट छ एउटा इनइफिसियन्ट छ अच्छा उसले चाहिँ टेलर्सको कुरा चाहिँ के छ भन्दाखेरि यदि efficient in inefficient टेलर्सको चाहिँ भनाइ के छ भन्दाखेरि यदि कोही लेबर इफिसियन्ट छ भने है र इनइफिसियन्ट छ भने चाहिँ उसको चाहिँ पेमेन्ट चाहिँ कस्तो प्रकारले गर्छ भनेर चाहिँ उनले चाहिँ अब यसलाई अलिकति बुझाइदिएको छ अब फ्याक्ट्रीमा के भएछ भन्दाखेरि यदि कोही एउटा लेबर छ अरे है त्यो लेबरले चाहिँ के गर्छ भन्दाखेरि उसले युनिट प्रड्युस पनि गर्दछ अन्त इफिसियन्ट छ कि छैन त्यो चेक गर्दछ है अच्छा इफिसियन्ट हो कि हैन कसरी चेक गर्छ भन्दाखेरि हामीलाई स्ट्यान्डर्ड आउटपुट र एक्चुअल आउटपुट हुनु जरुरी छ स्ट्यान्डर्ड आउटपुट भनेको चाहिँ फ्याक्ट्रीले के भनेको छ भन्दाखेरि त्यो डिपार्टमेन्टले चाहिँ त्यो अब प्रड्युस गर्ने बेलामा कतिवटा युनिट प्रड्युस गर्नु भनेको छ है र एक्चुअल चाहिँ त्यो लेबरले चाहिँ कति युनिट प्रड्युस गर्यो मानिलियौँ 100 वटा युनिट प्रड्युस गर्नु भन्दाखेरि लेट्स से मिस्टर एक्सले 150 प्रड्युस गर्नु सक्छ उसको एक्चुअल आउटपुट हो मिस्टर वाईले 90 गर्नु सक्छ है अब फ्याक्ट्रीले चाहिँ भन्दछ उनीहरूलाई जुन चाहिँ त्यो डिपार्टमेन्टमा काम गर्दछ 100 वटा युनिट प्रड्युस गर्नु भन्दैछ यो स्ट्यान्डर्ड भइहाल्यो र उसले कति चाहिँ प्रड्युस गर्यो यसलाई चाहिँ हामीले एक्चुअल आउटपुट भन्छ र यसलाई नै अब हामीले कम्पेयर गर्दाखेरि इफिसियन्ट हो कि इनइफिसियन्ट हो त्यो चाल पाइहाल्छ ठीक छ इफिसियन्ट र इनइफिसियन्ट अच्छा अब भनेको छ यसमा चाहिँ यदि कोही वर्कर इफिसियन्ट छ भने चाहिँ है इफिसियन्ट छ भने चाहिँ उसलाई 120% अफ नर्मल वेज रेट दिनु अरे इनइफिसियन्ट छ भने चाहिँ 80% अफ नर्मल वेज रेट ठीक छ अच्छा अब यो केसमा के हुन्छ भन्दाखेरि मैले अघि के भने यो स्ट्यान्डर्ड भयो यो एक्चुअल भयो यदि स्ट्यान्डर्ड र एक्चुअललाई मैले कम्पेयर गरेँ भने मिस्टर एक्स को केसमा के देख्छु भन्दाखेरि मिस्टर एक्सले त 50 युनिट्स बेसी पो प्रड्युस गरिरहेको छ त मिस्टर एक्स त इफिसियन्ट भयो है। अच्छा इफिसियन्ट भयो भने चाहिँ के हुन्छ अरे 120% अफ नर्मल वेज रेट उसले चाहिँ के पाउँछ भन्दा जुन चाहिँ नर्मल वेज रेट छ त्यसको 120% पाउँछ भने जस्तै कि एउटा युनिट बनाउनुको लागि 10 रुपीज हो भने उसले 10 रुपीजको चाहिँ कति पाउँछ अरे 120% पाउँछ भनेको ठीक छ। यो मिस्टर एक्स को केस भयो। अब वाई को केसमा के हुन्छ वाईलाई हेऱ्यो भने हामी इनइफिसियन्ट भन्छ 100 वटा बनाउनु पर्ने मैले 90 खाली बनाउँदैछ त्यतिखेर चाहिँ उसले कति पाउँछ अरे 80% अफ नर्मल भन्नुको मतलब जुन चाहिँ 10 रुपीज छ 10 रुपीजको 80% है यो त नर्मल। अब यसैमा अब हामीले इन्टु उसले कतिवटा युनिट प्रड्युस गर्यो 150 इन्टु र उसको 90 इन्टु युनिटलाई त हामीले मल्टिप्लाई गर्नु पर्यो नि त र यो प्रकारले उसको टेलर सिस्टममा चाहिँ यो प्रकारले उनीहरूले चाहिँ पेमेन्ट गर्छ भन्छ। अच्छा अब हामी टेलरको त अब हामीले यो वेज सिस्टम हामीले बुझ्यो। अब मेरिक्सको पनि बुझिराखौँ। मेरिक्सले पनि के भनेको छ भन्दाखेरि त्यस्तै कुरा गरेको छ मेरिक्सले चाहिँ टेलरको जुन चाहिँ यो थ्योरी छ जुन चाहिँ पेमेन्ट गर्ने सिस्टम छ त्यसलाई अलिकति मोडिफाई गरेको छ है। अच्छा मेरिक्सको चाहिँ कुरा के छ भन्दाखेरि यदि यहाँ लेखिदिन्छु है तिमीहरूलाई यो भयो तिमीहरूको टेलर सिस्टम टेलर्स। अब मेरिक्सले चाहिँ के भनेको छ भन्दाखेरि लेस देन 83% कसैले काम गर्यो भने उसले सिधै नर्मल वेज रेट पाउँछ अरे। अब कसैले मोर देन 83% बट लेस देन 100% गर्दछ भने चाहिँ उसले 110% अफ नर्मल वेज रेट पाउँछ अरे। कोही छ अरे मोर देन 100% छ भने चाहिँ 120% अफ नर्मल वेज रेट पाउँछ भन्दा चाहिँ यो चाहिँ मेरिक्सले कुरा गर्दछ। मेरिक्सको सिधै कुरा छ। अब कोही 83% भन्दा बिलो काम गर्यो भने चाहिँ उसलाई सिधै नर्मल जस्तो कि अघि केसमा हामीले 10 रुपीज 10 रुपीज खाली पाउँछ है। तर कोही 83 देखि 100 को बिचमा कसैले परफर्म गर्यो भने चाहिँ उसले 110% अफ नर्मल वेज रेट पाउँछ अरे। कोही वर्कर्स अरे 100% भन्दा बेसी गर्यो भने चाहिँ उसले चाहिँ 120% अफ नर्मल वेज रेट पाउँछ भन्दैछ ठीक छ। अच्छा अब हामीलाई कसरी चाहिँ थाहा हुनु यसमा चाहिँ इफिसियन्ट छ कि छैन। जस्तै कि अघि हामीले टेलरको सिस्टममा त के याद गर्यो स्ट्यान्डर्ड जति थियो उसले कति प्रड्युस गर्दछ इफिसियन्ट बुझिगयो हामी इफिसियन्ट हो कि इनइफिसियन्ट हो। तर अब यसको केसमा चाहिँ कस्तो हुन्छ भन्दाखेरि मेरिक्सको केसमा चाहिँ हामीले इफिसियन्सी लेभल चेक गर्नुपर्छ। इफिसियन्सी लेभल चेक गर्नुको लागि हाम्रो फर्मुला के हो भन्दाखेरि एक्चुअल आउटपुट डिवाइडेड बाय स्ट्यान्डर्ड आउटपुट इन्टु 100 कतिवटा प्रड्युस गर्यो कतिवटा गर्नुपर्नेमा त्यसलाई मल्टिप्लाई बाइ 100 गर्यो भने हाम्रो के आउँछ इफिसियन्सी लेभल पनि आउँछ। जब इफिसियन्सी लेभल आयो भने हामीले यो क्याटेगोरीमा चाहिँ चेक गर्नुपर्छ। यो मानिलिउँ कोही एउटा छ अरे मिस्टर एक्स छ अरे उसको हामीले इफिसियन्सी लेभल चेक गर्दाखेरि मानिलिउँ उसको इफिसियन्सी लेभल 60% आयो भने त लेस देन 83 भन्दा उसले नर्मल पाइहाल्छ। वाई छ अरे वाईको चाहिँ के पायो भन्दाखेरि हामीले 93% पायो अरे है। 93% पायो भने त 83 टु 100 को बिचमा लाई गर्यो उसले 110 पायो है। जेड छ अरे मिस्टर जेडले चाहिँ के गरेछ भन्दाखेरि उसले चाहिँ उसको इफिसियन्सी लेभल चेक गर्दा 110 भयो अरे। त्यसो भए 100 उसको मोर देन 100 भयो भने उसले 120% अफ नर्मल वेज रेट पाउँछ। सो यो चाहिँ हामीले चाहिँ के बुझ्यो भन्दाखेरि टेलर्स र मेरिक्सले चाहिँ कस्तो प्रकारले चाहिँ वेज पेमेन्ट गर्छ त्यो चाहिँ अहिले हामीले यहाँ बुझ्यो है। थ्योरी अब थ्योरिटिकली बुझ्यो। अब एक दुईवटा हामी यहाँ सम्स गरौँ प्र्याक्टिकल गरौँ हामी त्यहाँबाट अझै क्लियर हुँदै जान्छ। अच्छा यहाँ एउटा क्वेसन छ यो तिमीहरूको HS 2016 मा आएको यो प्रब्लम अच्छा यसमा क्वेसन यस्तो प्रकारले दिएको छ फ्रम द फलोइङ इन्फर्मेसन क्याल्कुलेट टोटल अर्निङ्स अफ इच वर्कर दुईटा वर्करको हामीले अर्निङ्स निकाल्नु पर्ने रहेछ स्ट्यान्डर्ड प्रोडक्सन दिएको छ हामीलाई स्ट्यान्डर्ड प्रोडक्सन स्ट्यान्डर्ड प्रोडक्सन दिएको छ 48 युनिट्स पर डे अफ 8 आवर्स भन्दैछ हामीलाई स्ट्यान्डर्ड प्रोडक्सन दिएको छ नर्मल वेज रेट दिएको छ नर्मल वेज रेट छ 72 रुपीस पर आवर अच्छा यहाँ डिफरेन्शियल वेज रेट चाहिँ के दिएको छ भन्दाखेरि 80% अफ नर्मल पिस रेट वेन बिलो स्ट्यान्डर्ड यो चाहिँ बिलो स्ट्यान्डर्ड छ भने अरे है अर्को छ 120% अबभ स्ट्यान्डर्ड छ भने र यहाँ के भएछ भन्दाखेरि प्रोडक्सन अफ X एन्ड Y इन अ स्पेसिफिक डे अफ 8 आवर्स र उनीहरूले 8 आवर्स काम गर्छ अरे है एक दिनमा चाहिँ उनीहरूले कति आवर्स काम गर्छ अरे 8 आवर्स र 8 आवर्स काम गर्दाखेरि चाहिँ 8 आवर्स काम गर्दाखेरि चाहिँ X ले 40 युनिट्स र Y ले 60 युनिट्स चाहिँ प्रोड्युस गर्यो भन्दैछ र अब हामीले यहाँदेखि चाहिँ हामीले के निकाल्नु पर्यो अर्निङ्स निकाल्नु पर्यो अच्छा अब हामीलाई के दिएको छ भन्दाखेरि हामीले के बुझ्छ भन्दाखेरि स्ट्यान्डर्ड प्रोडक्सन चाहिँ अब उनीहरूले भन्दैछ फ्याक्ट्रीमा अब काम गर्नेलाई के भन्दछ भन्दाखेरि दिनमा 8 घण्टा काम गर्नुपर्छ अरे तर 8 घण्टा काम गर्दाखेरि चाहिँ उसले 48 वटा युनिट्स चाहिँ उनीहरूले के गर्नु पर्यो प्रोड्युस गर्नु पर्यो ठिक छ अन्त अर्को कुरा के छ भन्दा नर्मल वेज रेट चाहिँ हामीलाई 72 रुपीस पर आवर दिएको छ यो 72 रुपीस हामीलाई पर आवरमा दिएको छ उसले युनिट प्रोड्युस गर्दछ 48 वटा है अच्छा जब वेज रेट निकाल्छ हामीले यो वेज रेट अब यो त अब हामीले सरासर के बुझ्यो भन्दा टेलर सिस्टममा दिइराखेको छ यो 80% र 120 र वेज रेट चाहिँ के हुन्छ भन्दा हामीले पिसमा त गर्दैन त्यो मतलब अब सरी आवरमा त गर्दैन हामीले यसलाई त पिसमा निकाल्नुपर्छ जस्तै अब यो नामै के छ डिफरेन्शियल पिस रेट सिस्टममा गर्छ टेलरको त पिसमा आउनु पर्यो तर यो त हामीलाई रेट केमा दिएको छ आवर्समा दिएको छ है अच्छा अब यसलाई अब हामी के गर्नु भन्दाखेरि पहिला अब हामीले नर्मल पिस रेट खोजौँ है त पहिला नर्मल यो सल्युसन तिमीहरूको अच्छा नर्मल पिस रेट चाहिँ अब हामीले कसरी निकाल्छ भन्दाखेरि हामीलाई कतिवटा युनिट्स बनाउनु भनेको छ 48 वटा युनिट्स हामीले 48 वटा युनिट्स प्रोड्युस गर्नुपर्ने हो कति घण्टामा हामीले 48 वटा युनिट्स बनाउनु 8 आवर्समा बनाउनु पर्ने हो है 48 वटा युनिट्स बनाउनु पर्ने हो कति आवर्समा 8 आवर्समा र पर आवरको रेट कति रहेछ 72 रुपीस अच्छा यसलाई क्याल्कुलेट गर्दाखेरि आउँछ म यही क्याल्कुलेट गरिहाल्छु यो आउँछ र नर्मल पिस रेट चाहिँ कति रहेछ 12 रुपीस रहेछ अब हामीले के बुझ्यौ भन्दाखेरि एउटाको दाम चाहिँ 12 रुपीस रहेछ नि त है अच्छा 12 रुपीस हो भने अब हामी के गर्छौँ भन्दाखेरि उनीहरूले कति घण्टा काम गरेछ 8 घण्टा गर्नुपर्ने 8 घण्टा 8 आवर्स नै हो 8 आवर्स काम गर्दाखेरि चाहिँ उसले प्रोड्युस कति गर्छ 40 युनिट्स उसले प्रोड्युस गर्छ 60 युनिट्स गर्नुपर्ने हो कति 48 अब हामीले के देख्छौँ भन्दाखेरि X चाहिँ इनइफिसियन्ट रहेछ Y चाहिँ इफिसियन्ट हो किन भन्दाखेरि X ले 48 वटा नबनाएर 40 वटा खालि बनाएछ नि त र Y ले कतिवटा बनाउनु पर्ने हो 48 बनाउनु पर्नेमा उसले 60 बनायो भने त ऊ त अबभ स्ट्यान्डर्डमा गयो नि त है अब यिनीहरूको अब यसले गर्दाखेरि जुन चाहिँ अब हामीले अर्निङ्स निकाल्नु पर्ने छ अब अर्निङ्समा हेरौँ अर्निङ्स अब पहिला हामी अर्निङ्स निकालौँ अर्निङ्स अफ X 40 वटा युनिट्स उसले प्रोड्युस गर्यो 40 वटा युनिट प्रड्युस गर्दाखेरि रेट हो ₹12 ऊ बिलो स्ट्यान्डर्डमा आयो यसको 80% है अच्छा 40 into 12 into 80% भयो भने हाम्रो आउँछ 9.6 र यसलाई फेरि हामीले 40 ले मल्टिप्लाई गर्यो भने आउँछ ₹384 र फर्स्टमा अब हामीले जुन चाहिँ अर्निङ्स निकाल्यो x को त कति रहेछ 384 पाउने रहेछ अब अर्निङ्स अफ y ले कति प्रड्युस गर्यो भन्दाखेरि 60 वटा युनिट प्रड्युस गर्यो 12 पिस गरेर पाउनु पर्ने तर ऊ अबभ स्ट्यान्डर्ड भएकोले गर्दाखेरि 120% पायो उले है र 60 into 12 into 120% भन्यो भने आयो 14.4 यो 14.4 चाहिँ रुपीजमा हो र यसलाई 60 ले मल्टिप्लाई गर्यो भने आउँछ ₹864 चाहिँ उले पाउने भयो र अब यसरी नै अब हामीले टेलर सिस्टममा चाहिँ के बुझ्यो भन्दाखेरि कोही अबभ स्ट्यान्डर्ड हुन्छ कोही बिलो स्ट्यान्डर्ड हुन्छ त्यो चाहिँ क्वेसनमा कोही बेला क्वेसनमा यसरी मेन्सन गरेकै हुन्छ कोही बेला यो चेन्ज पनि हुन सक्छ एज पर द क्वेसन चेन्ज पनि हुन सक्छ त्यतिखेर जस्तो क्वेसनमा दिएको छ त्यही गर्नु यदि दिएको छैन टेलर सिस्टममा गर्नु भने तिमीहरुलाई त 80 र 120 मैले अघि पढाइसकेको नै छु बुझ्यो अच्छा यो भयो हाम्रो टेलर सिस्टम है फेरि एउटा प्रब्लम गरौँ हामी यो 2018 मा आएको छ HS 2018 कै प्रब्लम गरौँ हामी यो क्वेशनमा के भनेको छ भन्दाखेरि स्ट्यान्डर्ड टाइम पर युनिट 4 मिनट्स normal rate of wages per hour 75 rupees differential wage rate below standard 80% of normal rate of wages per unit at or above standard 120% of normal rate of wages per unit भन्नु मतलब यसमा पनि टेलरकै सिस्टम दिएको रहेछ in a week of 48 hours production of A B and C are as below A 600 units B 720 units C 960 units अच्छा अब हामीलाई यसमा पनि के दिएको छ भन्दाखेरि स्ट्यान्डर्ड टाइम दिएको रहेछ 4 मिनट्स है नर्मल वेज रेट दिएको छ नर्मल वेज रेट छ ₹75 अच्छा यसमा पनि 80 र 120 अघिको जस्तो ठीक छ यो टेलर सिस्टमको जस्तै 80 र 20 बिलो स्ट्यान्डर्ड छ भने 80 अब स्ट्यान्डर्ड छ भने 120 48 आवर्स काम गर्दो रहेछ उनीहरूले 48 आवर्स इन अ विक त्यसमा 48 आवर्समा चाहिँ ए को प्रोडक्सन छ 600 युनिट्स बी 720 युनिट्स सी को छ 960 युनिट्स अच्छा अब हामीलाई यहाँ के दिएको छ स्ट्यान्डर्ड टाइम दिएको छ 4 मिनट्स नर्मल वेज रेट दिएको छ 75 नर्मल वेज रेट यो चाहिँ यस्तो छ नर्मल रेट पर आवर है यो चाहिँ पर 1 आवरमा चाहिँ 75 पाउँदो रहेछ अच्छा अब हामी यहाँ के यहाँबाट के छ पाउँछ स्ट्यान्डर्ड टाइम दिएको छ अब हामी यहाँबाट के निकालौँ भन्दाखेरि स्ट्यान्डर्ड प्रोडक्सन पर आवर है 1 घण्टामा चाहिँ कति बनाउन सक्छ स्ट्यान्डर्ड प्रोडक्सन र हामी यहाँ लेखौँ 1 आवरको उसको प्रोडक्सन हेरौँ स्ट्यान्डर्ड प्रोडक्सन पर आवर अच्छा स्ट्यान्डर्ड प्रोडक्सन पर आवरमा हेर्यो भने अब हामीले यहाँ के देख्दछ भन्दाखेरि 4 मिनट्स जसको स्ट्यान्डर्ड टाइम हो नि त है 4 मिनट्स अच्छा उसले अब हामीले टाइम 4 मिनट्समा उसले कति बनाउनु पर्यो एउटा बनाउनु पर्यो यो 4 मिनट्समा स्ट्यान्डर्ड टाइम एउटा दिएको छ र अब हामीले यसलाई केमा कन्भर्ट गर्दछ भन्दाखेरि यसलाई पर आवरको चाहिँ अब मिनटमा कन्भर्ट गर्यो भने इन्टु 60 गर्नु पर्यो है 1 आवरको हैन किनकि 4 मिनट्समा एउटा प्रोडक्सन गर्दैछ भने 1 घण्टामा कति प्रड्युस गर्छ भने त्यसो भए यो सिधै कति भयो 12 वटा युनिट्स उसले 1 आवरमा प्रड्युस गर्नु पर्ने रहेछ त सो 1 आवरमा उसले कति प्रड्युस गर्छ भन्दाखेरि 12 वटा युनिट्स उसले प्रड्युस गर्नु पर्यो अब फेरि अब हामी हेरौँ 1 आवरमा उसले 12 युनिट प्रड्युस गर्छ भने 48 आवर्समा चाहिँ उसले कति प्रड्युस गर्छ किनकि हामीलाई त टाइम त 1 विकमा त 48 आवर्स हो नि त 48 आवर्सको त अब फेरि हामीलाई स्ट्यान्डर्ड प्रोडक्सन चाहियो है स्ट्यान्डर्ड प्रोडक्सन फर 48 आवर्स यो त अब हामीलाई 1 आवरको खाली थाहा छ अब 48 आवर्समा उसले कति प्रड्युस गर्छ यहाँ लेखौँ सरी यो 12 होइन 15 युनिट्स है यो कति हुन्छ त्यसो भए 15 इन्टु 48 गर्दाखेरि 720 पो युनिट प्रड्युस त्यसो भए स्ट्यान्डर्ड त 720 पो रहेछ त अब यहाँदेखि हामीले के चाल पाउँछ भन्दाखेरि को बिलो स्ट्यान्डर्ड र को अबभ स्ट्यान्डर्ड है अच्छा यो अब हामीले स्ट्यान्डर्ड प्रोडक्सन फर 48 आवर्स पनि पायो अब नर्मल वेज रेट निकालौँ अब हाम्रो नर्मल किनकि हामीलाई वेज रेट त थाहा छैन त नर्मल वेज रेट चाहिँ कति हो भनेर अच्छा नर्मल वेज रेट अब हाम्रो कति हुनसक्छ भन्दाखेरि पर आवर कतिवटा हो 75 रुपिस हाम्रो पर आवर दिएको छ पर आवर 75 रुपिस छ र हामीले 1 आवरमा कतिवटा युनिट प्रड्युस गर्दछ 15 वटा प्रड्युस गरे कि गरेन र यो गऱ्यो भने आउँछ हाम्रो 5 रुपिस र हाम्रो नर्मल पिस रेट चाहिँ या वेजेस रेट चाहिँ कति रहेछ भन्दाखेरि 5 रुपिस हो भनेर चाल पाउँछ अच्छा अब हामी इफिसिएन्ट हो कि इनइफिसिएन्ट हो कसरी चाल पाउँछ भन्दाखेरि स्ट्यान्डर्ड 720 युनिट चाहियो एले 600 युनिट बनायो भने त उ त इनइफिसिएन्ट भयो 720 अब यो पारमा छ है यो इफिसिएन्टमै कन्सिडर गर्छ हामी 960 720 यो पनि के छ इफिसिएन्टमै छ अच्छा अब हामी यसको लागि फेरि हामी अर्निङ्स निकालिदिउँ अच्छा अर्निङ्सको लागि फेरि अर्निङ्स अफ एले कतिवटा प्रड्युस गरेको 600 इन्टु हाम्रो अहिले रुपिस 5 आयो उ त बिलो स्ट्यान्डर्ड भयो 80% है 600 इन्टु रुपिस कता आयो 42400 अर्निङ्स अफ बी 720 इन्टु 5 रुपिस अफ 120% 720 इन्टु रुपिस 5 इन्टु 120% गर्दा आउँछ यो 6 यो आयो 4320 अर्निङ्स अफ सी 960 वटा प्रड्युस गर्यो रुपिस 5 इन्टु 120% 960 इन्टु रुपिस 6 960 इन्टु 6 गर्यो भने आयो रुपिस 5760 र यो चाहिँ हामीले अर्निङ्स क्याल्कुलेट गर्यो तीनैजना वर्करको टेलर सिस्टममा ठिक छ अच्छा यो मेरिट सिस्टम चाहिँ कस्तो छ भन्दाखेरि यहाँ एउटा यो प्रब्लम पनि छ यही प्रब्लमबाट तिमीहरूलाई मेरिट सिस्टम पनि म गराइहाल्छु यहाँ के भनेको छ भन्दाखेरि हामीलाई मेरिट सिस्टममा चाहिँ अन द बेसिस अफ द फलोइङ इन्फर्मेसन क्याल्कुलेट द अर्निङ्स अफ ए एन्ड बी अन्डर मेरिट मल्टिपल पिस रेट सिस्टम अच्छा मेरिटको मेथडमा आएको छ अब हामी मेरिट्सको मेथडमा अब हामीलाई क्याल्कुलेट गर्नु भनेको छ स्ट्यान्डर्ड प्रोडक्सन दिएको छ स्ट्यान्डर्ड प्रोडक्सन है स्ट्यान्डर्ड प्रोडक्सन चाहिँ कति छ भन्दाखेरि 8 युनिट्स पर आवर नर्मल टाइम पनि दिएको छ हामीलाई नर्मल टाइम रेट कति छ भन्दाखेरि रुपिस 40 पर आवर इन अ 9 आवर डे अब 9 आवरको काम हुँदो रहेछ पर डे इन अ 9 आवर डे एले प्रड्युस गरेछ 54 युनिट्स बी को छ 72 युनिट्स, सी को छ 90 युनिट्स। अच्छा यो चाहिँ मेरिट सिस्टममा गर्नु भन्दैछ है। हामीलाई नर्मल रेट पनि दिएको छ। नर्मल रेट 40 रुपीस छ, स्ट्यान्डर्ड प्रोडक्सन 8 छ। अब सिधै नर्मल पनि टाइम पनि दिएको छ। 1 आवरमा उसले 8 युनिट्स पनि बनाउनु भनेको छ, फेरि 1 आवरको 40 रुपीस पनि रहेछ है। अब सिधै यहाँदेखि चाहिँ अब हामी वेज रेट निस्किहाल्यो है, वेज रेट। अच्छा वेज रेट चाहिँ कसरी निस्किन्छ भन्दाखेरि अब हामीले काम गर्नुपर्ने कति हो 8 आवर्स, स्ट्यान्डर्ड प्रोडक्सन भनेको चाहिँ सरी नट 8 आवर्स, उसले स्ट्यान्डर्ड प्रोडक्सन चाहिँ 8 युनिट्स पर आवर है। 1 आवरमा चाहिँ उसले कतिवटा युनिट्स बनाउनु भन्दैछ भन्दाखेरि 8 युनिट्स। अच्छा 8 युनिट्स बनाउँछ उसले 1 आवरमा है। 1 आवर फेरि रेट छ 40 रुपीस र कति रुपीस 5 आइहाल्यो नि त वेज रेट है। उसले 8 वटा युनिट्स कति आवरमा बनाउँछ 1 आवरमा बनाउँछ। 1 आवरको रेट कति हो 40 रुपीस हो र क्यान्सल गर्दाखेरि 5 रुपीस चाहिँ अब हाम्रो के आयो वेज रेट आयो। अब 5 रुपीस चाहिँ वेज रेट आयो, तर अब हामीलाई के थाहा छ भन्दाखेरि स्ट्यान्डर्ड प्रोडक्सन त 1 आवरको पो हामीलाई थाहा छ त 8 युनिट्स, तर इन अ डे उसले 9 आवर्स काम गर्छ भने अब स्ट्यान्डर्ड प्रोडक्सन त हामीलाई थाहा छैन है। स्ट्यान्डर्ड प्रोडक्सन फर 9 आवर्स गर्नु पर्यो। अच्छा उसले 8 वटा युनिट्स बनाउँछ, 8 युनिट्स इन्टु 9 र 72 वटा युनिट्स बनाउनु पर्नेमा ए ले 54 बनाएछ, बी ले 72 बनाएछ, सी ले 90 वटा युनिट्स बनाएछ। अच्छा अब यो त टेलर सिस्टम भएको पो त सिधै हामीलाई के चाल पाउँथ्यो भन्दाखेरि को इफिसियन्ट हो को इनइफिसियन्ट है यो स्ट्यान्डर्डमा कम्पेयर गर्दाखेरि। तर अब हामीलाई त यो त मेरिटको सिस्टममा हामीले चेक गर्नुपर्छ अब उसको कुन चाहिँ लेभल अफ इफिसियन्सीमा आउँछ है। सो लेभल अफ इफिसियन्सी चेक गर्नुको लागि चाहिँ नाउ व्हाट विल डू, नाउ विल क्याल्कुलेट इफिसियन्सी लेभल। अघि मैले इफिसियन्सी लेभलको नि फर्मुला तिमीलाई दिएकै छु। अब म यहाँ लेख्छु इफिसियन्सी लेभल इक्वल्स टू फर्मुला के हो एक्चुअल आउटपुट डिवाइडेड बाई स्ट्यान्डर्ड आउटपुट इन्टु 100 है। इफिसियन्सी लेभल अफ कसको भन्दा ए को एक्चुअल आउटपुट, ए को एक्चुअल कति छ 54 युनिट्स हो, स्ट्यान्डर्ड कति हुनुपर्ने 72 इन्टु 100 है। अब 54 इन्टु 100 डिवाइडेड बाई 72 गऱ्यो भने 75% मा आउँदो रहेछ। इफिसियन्सी लेभल अफ बी उसको एक्चुअल कति हो भन्दाखेरि 72 हो बाई स्ट्यान्डर्ड पनि 72 हो इन्टु 100, उसको त सिधा 100% आइगयो। इफिसियन्सी लेभल अफ सी, सी ले कति प्रड्युस गर्यो भन्दाखेरि सी ले 90 युनिट प्रड्युस गर्यो 72 वटा गर्नुपर्नेमा। सो 90 इन्टु 100 डिवाइडेड बाई 72 गर्दाखेरि आउँछ 125%। सो यसले के बुझ्छ भन्दाखेरि 75% त उसले नर्मल वेज रेट पाउँछ अरे, कसैले 100% नर्मल वेज रेट पाउँछ अरे, कसैले 125% नर्मल वेज रेट पाउँछ भन्दैछ। अच्छा अब यहाँबाट फेरि अब हामीले अर्निङ्स निकाल्नु पर्यो। अर्निङ्स अफ ए 54 वटा युनिट प्रड्युस गरेकोले है, 54 वटा युनिट प्रड्युस गर्दछ। अच्छा अब हामी यहाँ के बुझ्छ भन्दाखेरि ए ले त प्रड्युस गरेको 54 वटा युनिट्स हो। हामीलाई मेरिटको सिस्टममा के थाहा छ भन्दाखेरि जसले 83% भन्दा बिलो प्रड्युस गर्छ उसले त नर्मल पाउँछ नि त है, नर्मल वेज रेट। 54 इन्टु उसको नर्मल वेज रेट कति हो 5 रुपीस हो है, 5 रुपीस खालि हो त, किनकि नर्मल वेज रेट खालि पाउँछ अरे। उसले कति पाउने रहेछ 270 है। अब अर्निङ्स अफ बी लाई चेक गर्यो भने बी ले प्रड्युस गर्दछ हाम्रो 72 युनिट्स इन्टु 5 रुपीस त हो। बी को हेऱ्यो भने 100% एफिसियन्सी छ र 83 देखिको र 100% को बीचमा लाई गर्यो भने 110% पाउँछ भन्दै थियो अघि हैन। र 72 इन्टु फेरि यसलाई मल्टिप्लाई गरौँ 5 इन्टु 110 पर्सेन्ट गरे पनि आयो रुपीस 5.5 72 रुपीस 396 अर्निङ्स अफ सी ले कति प्रोड्युस गरेछ हामी देख्छ 90 युनिट्स इन्टु 5 रुपीस हो सी को हेऱ्यो भने 125 अब फेरि 100 अबभ 100 हो भने त 120% थियो मेरिक्स को 120%. So 90 into 5 into 120% गऱ्यो भने 6 रुपीस आउँदछ 6 9 54 540 रुपीस पाउने रहेछ सी ले. सो यो प्रकारले चाहिँ अब हामीले मेरिकको सिस्टममा पनि हामीले पेमेन्ट चाहिँ कस्तो प्रकारले चाल पाउँदो रहेछ भन्दाखेरि 270 ए को भइगयो बी को आयो 396 र सी को आयो 540. यो चाहिँ कसरी चाल पायो भन्दाखेरि इफिसियन्सी लेभल मैले तिमीहरूलाई अघि दिएको नै थिएँ. ठिक छ. अच्छा अब यो भयो हामीले टेलर र मेरिकको सिस्टम त गरे हामीले. अब हामी अर्को पार्ट चाहिँ कहाँ पुग्छ के गर्छ भन्दाखेरि हामी अब बोनस प्रिमियम गर्छ. बोनस प्रिमियममा अब हेल्से र रो हुन्छ है. अब यो चाहिँ मोटिभेट चाहिँ कस्तो प्रकारले गर्छ भन्दाखेरि अब तिमीहरूले धेरैवटा थ्योरी पढि पनि सकेको छ होला बिजनेस स्टडिजमा है. थ्योरिटिकल तिमीहरूले त्यहाँ पढिसकेको छौ. प्र्याक्टिकल चाहिँ अब कतिवटा अब इन्डस्ट्रीतिर चाहिँ अब हेल्से रोहनहरू चाहिँ उनीहरू अब पहिला उनीहरू चाहिँ अब कस्तो म्यानेजरहरू हुनुहुन्थ्यो उनीहरू त्यो जग्गामा चाहिँ उनीहरूले पेमेन्ट चाहिँ कस्तो प्रकारले गर्ने र मोटिभेट चाहिँ कसरी गर्ने वर्करहरूलाई मोटिभेट गर्नुको लागि चाहिँ उनीहरूले आफ्नो आफ्नो प्लान निकालेको थियो. ठिक छ. अब यो प्लान हेल्सेले के भन्दछ र रोहनले के भन्दछ. हेल्सेले भन्दैछ उसले अब जब टोटल अर्निङ्स दिन्छ है टोटल अर्निङ्सको लागि फर्मुला छ हेल्सेले भन्दछ टोटल अर्निङ्सको लागि नॉर्मल वेज रेट प्लस बोनस. नॉर्मल वेज रेट सँग उसले बोनस पनि दिने भयो है. अच्छा अब नॉर्मल वेज रेट चाहिँ के रहेछ. नॉर्मल वेज रेट चाहिँ कस्तो प्रकारले हो के हो भन्दाखेरि नॉर्मल वेज रेट चाहिँ जति हामीले काम गर्छ कति घण्टा काम गर्यो है अब कति आवर्स उसले काम गर्यो त्यसैमा उसले पायो टाइम टेकन कति घण्टामा उसले चाहिँ कति आवर्समा चाहिँ उसले काम कम्प्लिट गर्यो राइट. इन हाउ मेनी आवर्स ही हेज कम्प्लिटेड द जब. सो टाइम टेकन इन्टु रेट पर आवर मानिले 7 आवर्समा कम्प्लिट गर्यो 7 इन्टु अब रेट 5 रुपिस 7 इन्टु 5 गर्यो. यो त नर्मल रेट हो. अब बोनस बोनस चाहिँ के भनेको छ भन्दाखेरि जति हामीले टाइम सेभ गरेको छ ठिक छ जति टाइम सेभ है जति टाइम सेभ गर्यो उसलाई अब स्ट्यान्डर्ड दिएको छ 9 आवर्स 9 आवर्स मैले 7 आवर्समा कम्प्लिट गरेँ 2 आवर्स त टाइम सेभ भयो. टाइम सेभ इन्टु रेट पर आवर है. टाइम सेभ इन्टु रेट पर आवर जो जति पनि आउँछ त्यसको चाहिँ 50% खालि हेर्ने बोनस चाहिँ. यो चाहिँ भन्दछ हाम्रो हेल्से है. मानिलिउँ अब यसको एउटा सानो एउटा इक्जाम्पल लियो भने ए बी सी डी छ अरे. स्ट्यान्डर्ड टाइम छ अरे 8 आवर्स र वेज रेट छ अरे रुपीस 10 पर आवर है. एले कम्प्लिट गरे अरे आफ्नो टास्क 6 आवर्समा बीले कम्प्लिट गरे अरे 5 आवर्समा सीले गरे अरे 4 आवर्समा र डीले गरे अरे 10 आवर्समा. उनीहरूले चाहिँ यो चाहिँ आफ्नो पर्फर्मेन्स यो प्रकारले दियो अरे. एले 6 आवर्समा कम्प्लिट बी कम्प्लिटेड at 5 hours C at 4 D at 10 hours है उनीहरूले कम्प्लिट गरे अरे. अब यहाँदेखि चाहिँ अब हामीलाई हेल्से प्लानमा चाहिँ हेल्सेले चाहिँ के भनेको छ भन्दाखेरि सिधै छ फर्मुला टोटल अर्निङ्स के छ भन्दाखेरि टोटल अर्निङ्समा फर्स्ट हामीले नर्मल वेज गर्छौँ नर्मल वेजमा टाइम टेकन इन्टु रेट पर आवर टाइम टेकन कति 6 आवर्स उसले टाइम लियो रेट पर आवर 10 रुपिस छ है प्लस बोनसको 50% अरे 50% अफ टाइम सेभ अब उसले टाइम कति सेभ गर्यो 8 आवर्समा काम गर्नुपर्नेमा उसले 6 आवर्समा काम कम्प्लिट गर्यो 2 आवर्स उसले टाइम सेभ गर्यो र रेट पर आवर फेरि कति छ रुपिस 10 यो कति भयो 60 प्लस 20 को 50% भन्ने यो भयो 10 यो भयो रुपिस 70 ए को है टोटल अर्निङ यो ए अब बी को टोटल अर्निङ बी ले 5 आवर्समा कम्प्लिट गरेछ 5 आवर्समा कम्प्लिट गर्यो 10 रुपिस हो प्लस 50% अफ अब उसले कति टाइम सेभ गर्यो 3 आवर्स टाइम सेभ गर्दछ उसले है 3 इन्टु रुपिस 10 सो यो कति भयो 50 रुपिस भइगयो उसको चाहिँ यो बोनस कति भयो 3 इन्टु 10 30 को 50% भन्यो भने 15 रुपिस र उसको भयो 65 रुपिस सी को हेऱ्यो भने सी ले 4 आवर्समा उसले काम कम्प्लिट गरेछ 10 रुपिस हो प्लस 50% इन्टु 4 आवरमा कम्प्लिट गर्यो भने उसले टाइम सेभ पनि कति 4 आवर नै गर्यो 4 इन्टु रुपिस 10 यसको हाफ है फेरि 4 10 जा रुपिस 40 प्लस बोनस 40 को हाफ भन्यो भने रुपिस 20 र भयो रुपिस 60 अब डी ले त 10 आवर्समा काम कम्प्लिट गर्यो 10 इन्टु रुपिस 10 अब उसले कुनै टाइम सेभ गर्यो गरेन टाइम सेभै गरेर उसको त निल यो 0 पाउँछ उसले त बोनसै पाउँदैन है त्यसो भए 10 10 जा 100 अच्छा अब हामी यहाँ के देख्छ भन्दाखेरि तिमीहरूले अब यो एक्जाम्पल हेरेर के भन्नु सक्छ भन्दा अर्निङ्सलाई हेऱ्यो भने त डी पो एकदमै अब डीले पो 100 रुपिस लाँदैछ घरमा डीले है बेसी पैसा लिएर गयो दो उसले टाइम पनि सेभ गरेन उसले 10 आवर्समा काम कम्प्लिट गर्यो उसले 100 रुपिस लग्यो भन्दै गरेको हुन्छ अब वेयरएज यसमा हेऱ्यो भने चाहिँ उसले एकदमै छिटो काम कम्प्लिट गर्ने त सी हो है सीले सबभन्दा मिनिमम वेज लिएर जाँदैछ 60 रुपिस ठिक छ 60 रुपिस लिएर जाँदैछ सीले त्यस्तै प्रकारले हेऱ्यो भने ए ले 2 आवर सेभ गरेको 70 रुपिस लाँदैछ बी ले 3 आवर सेभ गर्यो 65 लग्यो सी ले त 4 आवर सेभ गर्दा पनि 60 रुपिस लाँदैछ डी ले त 100 रुपिस लाँदैछ विदाउट टाइम सेभिङ है उसको त बोनस पनि छैन र पनि 100 रुपिस लग्यो तिमीले त भन्नु सक्छौ डी पो एकदमै फाइदामा छ भन्छ तर हामीले हेऱ्यो भने चाहिँ के देख्छ भन्दाखेरि जो चाहिँ सी छ सी ले रुपिस 60 लगेको छ नि ऊ पो खासमा फाइदामा छ त सबभन्दा बेसी त सी छ फाइदामा सी ले 60 रुपिस लाँदैछ फाइदामा किन छ भन्दाखेरि अब कुरा यहाँ छ हेर है त काम गर्नुपर्ने त 8 घण्टा हो तर उसले 4 घण्टामा काम सकेन 4 घण्टा सेभ भयो कि भएन 4 घण्टा सेभ भयो भने उसले के गर्नु सक्छ भन्दाखेरि त्यो 4 घण्टा त फेरि उसले अर्को काममा युटिलाइज गर्न सक्छ हो किन फ्याक्ट्रीमा फेरि गएर उसले अर्को प्रोडक्सन गर्नु सक्छ अर्को प्रोडक्सन गर्दाखेरि फेरि उसले 4 आवर्सको त एक्स्ट्रा पैसा घरमा लिएर जान्छ नि त है त्यस्तै प्रकारले यहाँ पनि बीले पनि त कति टाइम सेभ गर्यो 3 आवर्समा त ऊ अरू काम गर्नु सक्छ फ्याक्ट्रीमा गएर उसले अरू युनिट प्रड्युस गरेर फेरि एक्स्ट्रा उसले पैसा लिएर जानु सक्छ र यहाँ भन्छ जसले छिटो काम सक्छ उसले त्यही हिसाबले नै बोनस पाउँछ र उसले अझै बेसी पाउँछ अरे बोनस किनकि एउटा काम सक्ने बित्तिकै उसले अर्को काम पाउँछ यो चाहिँ स्पिड वर्कको स्पिडमा डिपेन्ड गर्छ हेल्थ प्लानले चाहिँ यही भन्दछ है अच्छा अब रोन प्लानमा चाहिँ के भन्दो रहेछ अब हेर है त फेरि रोन प्लानको चाहिँ अब रोन प्लानले भन्दछ फेरि टोटल अर्निङ्स निकाल्नुको लागि नर्मल वेज रेट त हुनुपर्छ अरे प्लस बोनस है अच्छा नर्मल वेज रेट अघिको जस्तो टाइम टेकन इन्टु रेट पर आवर अच्छा बोनस यसको म डिस्कस गर्छु बोनस अच्छा यसको बोनस चाहिँ कस्तो प्रकारले दिने भएको छ भन्दाखेरि जति उसले टाइम सेभ गरेको छ है त्यसलाई चाहिँ फेरि टाइम टेकनले मल्टिप्लाई गर्नु डिभाइडेड बाई स्ट्यान्डर्ड टाइम एउटा दिएको स्ट्यान्डर्ड टाइममा चाहिँ उसले कति टाइम सेभ गर्यो है, त्यो कति टाइम सेभ गर्यो र कति टाइम सेभ गर्दाखेरि उसले त्यसमा चाहिँ उसले फेरि कति टाइम लियो उसले काम गर्ने बेलामा र यसले मल्टिप्लाई गर्नु अरे। अच्छा, अब बोनसमा के भनेछ, जति स्ट्यान्डर्ड टाइम छ स्ट्यान्डर्ड टाइममा उसले कति टाइम सेभ गर्यो है, अन्त उसले कति टाइम उसले टेकन गर्यो है, मतलब त्यो युनिट प्रड्युस गर्नुको लागि। अन्त वेज रेट मल्टिप्लाई बाइ वेज रेट, नर्मल वेज रेट जे छ उसको। अच्छा, त्यस्तै प्रकारले अब फेरि एउटा इक्जाम्पल हामी लिउँ अघिको जस्तै। उनीहरूको स्ट्यान्डर्ड टाइम जुन चाहिँ छ, स्ट्यान्डर्ड टाइम यसमा पनि 8 आवर्स, उनीहरूको वेज रेट 10 रुपिस, ए बी सी डी छ अरे। एले 6 आवर्समा काम गर्यो अरे, बीले 5, सीले 4, डीले 8 आवर्स। यसलाई यस्तो गरौँ, यसले 8 आवर्समा यसले 4 आवर्समा कम्प्लिट गर्यो अरे। अब अर्निङ्स अफ ए निकाल्नु पऱ्यो भने है, नर्मल जुन चाहिँ नर्मल वेज रेट छ, टाइम टेकन, अच्छा सिधै गर्छु, टाइम टेकन कति छ भन्दाखेरि टाइम टेकन हो 6 इन्टु रेट पर आवर पनि 10 रुपिस हो, प्लस अब यसको बोनस चाहिँ कस्तो प्रकारले छ भन्दा स्ट्यान्डर्ड टाइमले डिभाइड गर्नु अरे। स्ट्यान्डर्ड टाइम 8 आवर्स, टाइम सेभ उसले कति टाइम सेभ गर्यो 2 इन्टु टाइम टेकन कति हो भन्दाखेरि फेरि 6 हो। यसलाई फेरि हामीले केले मल्टिप्लाई गर्नु पर्यो, रेट जुन चाहिँ वेज रेट छ। यो भयो हाम्रो 60 प्लस रुपीस 15 रुपीस 75 भयो। बी को बीले टाइम कति लियो भन्दाखेरि 5 इन्टु रुपीस 10 प्लस कति टाइम सेभ गर्यो 3 आवर्स सेभ गरेछ। उसले टाइम कति लियो भन्दाखेरि 5/8 इन्टु रुपीस 10, उसको यो 50 रुपीस भइगयो। अब उसको बोनस चाहिँ म यहाँ क्याल्कुलेट गर्दैछु, 3 इन्टु 5 डिभाइडेड बाई 8 इन्टु 10 गर्दाखेरि 18.75 आयो, प्लस 50 गर्दा आउँछ रुपीस 68.75। सीले 8 आवर्समा कम्प्लिट गरेछ, 8 इन्टु रुपीस 10 प्लस सीले कति टाइम सेभ गर्यो भन्दाखेरि निल, उसको 0 छ है, 0 इन्टु टाइम टेकन 5/8, अब यो सबै 0 हुँदै जान्छ यो त है, यो 10 रुपिस छ, यो सबै 0 भयो र यसले 80 रुपिस लिएर जाने भयो। जो डी छ, डीले कति आवर्समा कम्प्लिट गर्यो 4 आवर्समा कम्प्लिट गर्यो र 4 इन्टु 10 प्लस यो त 8 हो। उसले टाइम कति सेभ गर्यो भन्दाखेरि 4 आवर्स नै सेभ गर्यो। टाइम टेकन कति लियो भन्दाखेरि 4 लियो उसले टाइम पनि, इन्टु रुपीस 10 र भयो 40 प्लस यो भयो रुपीस 20 र यो भयो रुपीस 60। अच्छा, अब यहाँ डीसम्म हामीले गरे। अच्छा, अझै एउटा थपौँ न त, यहाँ ई भन्ने पनि एउटा वर्कर छ अरे, ईले चाहिँ 2 आवर्समा कम्प्लिट गरे है, त्यस्तो स्पिडमा काम गरेछ ईले 2 आवर्समा कम्प्लिट गर्यो 10 रुपिस गरेर। ई को 2 आवर्समा उसले काम सक्यो 10 रुपिस हो। अच्छा, उसको स्ट्यान्डर्ड कति हो भन्दाखेरि फेरि स्ट्यान्डर्ड उसको 8 हो। टाइम कति सेभ गर्यो उसले पहिला हामी चेक गरौँ। टाइम सेभ उसले 2 आवर्समा कम्प्लिट गर्यो भन्दा 6 आवर्स उसले टाइम सेभ गर्यो, इन्टु टाइम टेकन उसको 2 हो, इन्टु रुपीस 10 है, 20 प्लस यसलाई गर्नु सक्छ 2 4 टाइम्स 2 2 2 3 2 5 रुपीस 15 र भयो रुपीस 35। अच्छा अब हामी यहाँ के देख्छ भन्दाखेरि एकजना छ 6 आवर्समा उसले कम्प्लिट गर्यो, एकजनाले 5 आवर्समा। अब सी को त कुरै नगरौँ, उसले त जति टाइम दिएको छ त्यतिमा उसले कम्प्लिट गरेको छ है। सी ले त उसले केही बोनसै लिएर गएन, उसको बोनस 0 छैन। अब बोनस लानेहरू जसले बेसी टाइम सेभ गरेको छ उनीहरूको बोनस त्यही प्रकारले नै बेसी हुँदै जाँदैछ। हेर त टाइम सेभ उसले कति गरेको थियो यसमा 2 टाइम सेभ गर्दाखेरि उसले 15 रुपिस गर्यो, उसको टाइम सेभिङ थियो 3 उसले 18.75 लग्यो, उसको टाइम सेभिङ 4 थियो उसले 20 रुपिस लग्यो। त्यस्तै हो भने ईले त टाइम सेभिङ त उसको हेऱ्यो भने 6 आवर्स हो नि त, तर यहाँ के देख्छ हामीले 15 रुपिस, यो बोनस चाहिँ उसले कम्ती पायो। भन्नुको मतलब चाहिँ के हो भन्दाखेरि जुन चाहिँ अब हाम्रो रोन प्लान छ, रोन प्लानमा चाहिँ जति तिमीले टाइम सेभ गर्छौ त्यति तिमीले चाहिँ बोनस बेसी लान्छौ, तर त्यसको पनि एउटा लेभल छ, एउटा लिमिट छ। जस्तो लिमिट चाहिँ के हो भन्दा 50% सम्म चाहिँ तिमीले बेसी लान्छौ, 50% भन्दा मुनि भयो भने चाहिँ तिमीले बोनस कम्ती लान्छौ। जस्तै कि यो केसमा हेऱ्यो भने ए र बी ले त टाइम सेभ गर्दाखेरि उनीहरूले 2 आवर्स र 3 आवर्स टाइम सेभ गरेको नि त, उनीहरूले 15 रुपिस र 18.75 लग्यो। तर डी को केसमा हेऱ्यो भने डी ले त 50% हाफ, उसको जति 8 आवर्स भन्दाखेरि 4 आवर्समा कम्प्लिट गर्यो, हाफमै उसले कम्प्लिट गर्यो भने यहाँसम्म 20 उसले पायो, ठिकै छ। तर यहाँ 4 देखि मुनि जब मैले ई पछि थपेँ, ई को चाहिँ के भयो भन्दा अझै कम्ती जब गर्छ 50% भन्दा कम्ती गऱ्यो भने चाहिँ बोनस त्यतिखेर के हुन्छ कम्ती पाउँदै जान्छ, ठिक छ, बोनस कम्ती हुँदै गयो। अच्छा यस्तो केसमा चाहिँ उनीहरूलाई चाहिँ फेरि पेनल्टी भएको नि, यो चाहिँ कम्ती पाएको नि, यो चाहिँ ठिक छ। अच्छा अब यो हामीले जस्ट एउटा इक्जाम्पलको उयसमा रूपमा हामीले बुझ्यौँ, अब यसको प्रब्लम पनि हामी गरौँ। एउटा HS 2016 मा आएको प्रब्लम छ है। यो प्रब्लममा के दिएको छ भन्दा TA भनेको टाइम अलाउड हो ल, TA टाइम अलाउड र TT भनेको चाहिँ टाइम टेकन। ए र बी वर्कर छ, टाइम अलाउड छ 50, टाइम टेकन छ 40 र 30। सो नर्मल वेज रेट रहेछ पर आवरमा ₹5. Compute total earnings of the above worker under the following method: टाइम रेट सिस्टम, हेल्से प्रिमियम प्लान र रोन प्रिमियम प्लान। अच्छा पहिला हामीलाई टाइम रेट सिस्टममा निकाल्नु भन्दैछ। अच्छा फर्स्ट नम्बर 1 लेखौँ, टाइम रेट सिस्टम। अच्छा टाइम रेट सिस्टममा त सजिलै के छ भन्दाखेरि फर्मुला टाइम टेकन इन्टु नर्मल वेज रेट हो। टाइम टेकन अब हामीलाई टाइम जुन चाहिँ टाइम रेट सिस्टम अब हामीले पहिला ए को गर्नु पर्यो भने है, अर्निङ्स ए को टाइम टेकन ए ले कति टाइम दियो 40 आवर्स इन्टु ₹5 हो र यो भयो 200 रुपिस। बी को गर्नु पर्यो भने 30 इन्टु ₹5 ₹150 है। यो त सजिलो छ, यो त आइ पनि गयो टाइम रेट सिस्टममा। अब अर्को भन्दैछ हामीलाई हेल्से प्लान। नम्बर 2 मा छ हेल्से प्लान। हेल्सेको अब अर्निङ्सको अब फर्मुला अघि तिमीहरूलाई मैले भनेको थिएँ है। अन्डर हेल्सेमा चाहिँ टोटल अर्निङ्स कसरी निस्किन्छ भन्दाखेरि टाइम टेकन इन्टु रेट पर आवर प्लस 50% अफ टाइम सेभ इन्टु रेट पर आवर हैन। अच्छा अब ए को टाइम कति दियो 40, रेट पर आवर छ ₹5 प्लस 50%। टाइम सेभ उसले कति गर्यो, अलाउड 50 हो, उसले 40 मा कम्प्लिट गर्यो भने 10 इन्टु रेट पर आवर चाहिँ कति हो 5, 200 प्लस 10 5 50, 50 का हाफ 25 भयो इक्वल्स टु ₹225। त्यस्तै प्रकारले बी को हेऱ्यो भने बी को टाइम टेकन 30 हो, ₹5 गरेर प्लस 50% अफ टाइम सेभ कति गर्यो उसले 20 हो टाइम सेभ इन्टु रेट पर आवर 5 रुपीज हो यो रुपीज 150 प्लस 5 इन्टु 20 100 भयो 100 को 50% भने रुपीज 50 र उसको आयो रुपीज 200 यो चाहिँ हेल्सेको सिस्टममा है सो हेल्सेले के भनेको छ भन्दाखेरि अघि नै भनेको थियो बोनस चाहिँ कस्तो पाउँछ भन्दाखेरि टाइम सेभ जति छ टाइम सेभलाई त्यसले रेट पर आवरले मल्टिप्लाई गर त्यसको 50% पाउँछौ तिमीहरूले अब अर्को अब हाम्रो रोन प्लानमा पनि सोधेको छ नम्बर 3 नम्बर 3 रोन प्लान रोन प्लानको पनि टोटल अर्निङ्स फर्मुला अघि मैले दिएको थिएँ तिमीहरूलाई टाइम टेकन इन्टु रेट पर आवर प्लस जति स्ट्यान्डर्ड टाइम दिएको छ स्ट्यान्डर्ड टाइममा उसले टाइम कति सेभ गर्यो इन्टु टाइम टेकन कति थियो त्यसलाई फेरि हामीले रेट पर आवरले मल्टिप्लाई गर्छ टाइम टेकन कति छ भन्दाखेरि अच्छा यो हाम्रो ए को टाइम टेकन हो 50 इन्टु रेट पर आवर रुपीज 5 प्लस टाइम सेभ हेऱ्यो भने ए को हेऱ्यो भने हामीलाई टाइम अलाउड त 50 हो तर उसले टाइम टेकन 40 गर्यो भने टाइम सेभ छ उसको 10 इन्टु टाइम टेकन फेरि कति हो भन्दाखेरि उसले 50 आवर्स उसले टाइम लिएको छ स्ट्यान्डर्ड टाइम हामीलाई उसको टाइम टेकन हो 40 हामीलाई स्ट्यान्डर्ड टाइम दिएको छ 50 इन्टु रेट पर आवर कति छ रुपीज 5 रुपीज 250 भइगयो प्लस 0058 टाइम्स र 8 5 40 यो 40 रुपीज र ए को भयो रुपीज 290 है अब त्यस्तै प्रकारले बी को पनि अब रोन प्लान निकाल्नु पर्यो भने टाइम टेकन रोन बी को 30 इन्टु रेट पर आवर रुपीज 5 प्लस टाइम सेभ उसको 20 इन्टु टाइम टेकन हो उसको 30 बाय उसको टाइम अलाउड हो 50 इन्टु रुपीज 5 रुपीज 150 भइगयो प्लस यो 00 क्यान्सल भयो नि 5 6 6 2 12 यस्तो गर्नु 12 इन्टु 5 60 रुपीज 210 यो चाहिँ बी को 210 आयो टाइम टेकन सरी यहाँ नम्बर ए को टाइम टेकन यो 40 हो सो 40 इन्टु 50 will give you 200 and this one is 240 सो यो अब हाम्रो भयो हेल्सेल र रोन प्लानको है यो सानो करेक्सन यहाँ 40 थियो यो हेल्सेल र रोन प्लानको यो प्रब्लम हामीले एउटा सल्भ गर्यो है यो चाहिँ 2016 मा आएको एचएस को अब एउटा 2018 मा आएको छ प्रब्लम 2018 को यो प्रब्लममा के छ भन्दाखेरि 2018 मा दिएको छ हामीलाई एउटा कमल एउटा हसन यो स्ट्यान्डर्ड टाइम दिएको छ पर आवर कमलको 40 रहेछ हसनको पनि 40 स्ट्यान्डर्ड टाइम सेभ पनि दिएको छ टाइम सेभ छ 8 यसको पनि 8 बोनस टाइम अलिकति चेन्ज भएको छ प्रब्लम बोनस टाइम छ 6.4 र 4 नर्मल वेज रेट दिएको छ 50 on the basis of the above information calculate for each of Kamal and Hassan number 1 total earnings and number 2 effective rate of earnings अच्छा हामीलाई टोटल अर्निङ्स निकाल्नु भनेको छ तर यसमा क्वेशनमा के ट्विस्ट गरेको छ भन्दाखेरि हामीलाई टाइम सेभ र बोनस टाइम दिएको छ है टाइम सेभ र बोनस टाइम दिएको छ अच्छा टाइम सेभ र बोनस टाइम जब दिएको हुन्छ अब हामीले यहाँदेखि चाहिँ के निकाल्नु सक्छ भन्दाखेरि टाइम टेकन है अब निकालौँ सल्युसन टाइम टेकन अच्छा एक्चुअल खासमा हाम्रो टाइम सेभको फर्मुला के हो भन्दाखेरि टाइम सेभको फर्मुला टाइम अलाउड माइनस टाइम टेकन हो नि त यहाँबाट नै टाइम टेकन हामीले कसरी निकाल्नु सक्छ भन्दाखेरि टाइम अलाउड माइनस टाइम सेभ हुन्छ कि हुँदैन टाइम अलाउड माइनस टाइम सेभ या टाइम अलाउड भनेको नै स्ट्यान्डर्ड टाइम हो है यसलाई स्ट्यान्डर्ड टाइम पनि भन्न सक्छ हामी स्ट्यान्डर्ड टाइम माइनस टाइम टेकन हामीलाई चाहिएको टाइम टेकनलाई उता लग्यो भने स्ट्यान्डर्ड टाइम माइनस टाइम सेभ र टाइम टेकनको फर्मुला त के बनिँदो रहेछ यहाँदेखि भन्दाखेरि स्ट्यान्डर्ड टाइम माइनस टाइम सेभ हो अच्छा अब टाइम टेकन कसको निकाल्नु पर्ने भन्दा पहिला कमलको स्ट्यान्डर्ड टाइम कति छ भन्दाखेरि 40 माइनस टाइम सेभ हो 8 उसको भयो 32 हसनको 40 हो स्ट्यान्डर्ड टाइम सेभ गरेको छ उसले 8 32 र दुईजनाको 32 आउँदो रहेछ अच्छा अब हामीलाई टोटल अर्निङ्स निकाल्नु भन्दैछ है अब नर्मली टोटल अर्निङ्सको फर्मुला अब हामीले के गर्छ भन्दाखेरि जुन चाहिँ अब हामीलाई नर्मल जुन चाहिँ हामीलाई टाइम दिएको हुन्छ नर्मल टाइममा अब हामीले त्यसलाई एड गर्दै जान्छ अब यसमा हामीलाई त के दिएको छ भन्दा स्ट्यान्डर्ड टाइम दिएको छ टाइम सेभ दिएको छ बोनस टाइमहरू दिएको छ अच्छा अब सिधै हाम्रो फर्मुला चाहिँ के हुन्छ भन्दाखेरि यतिखेर टोटल अर्निङ्स इक्वल्स टु है जुन चाहिँ टाइम टेकन छ अहिले हामीले टाइम टेकन निकालेको टाइम टेकनमा बोनस टाइमलाई जोड्नु पर्यो और यस्तो गरौँ न त जुन चाहिँ टाइम टेकन छ टाइम टेकनलाई हाम्रो नर्मल वेज रेटले मल्टिप्लाई गरौँ नर्मल वेज रेट है किनकि फर्मुला नै त्यस्तै छ नि त टाइम टेकन इन्टु नर्मल वेज रेट प्लस बोनस इन्टु फेरि नर्मल वेज रेट हो फेरि बोनस इन्टु नर्मल वेज रेट है अच्छा टाइम टेकन अब कमलको टाइम टेकन कति थियो भन्दाखेरि अघि हामी यहाँ क्याल्कुलेट गरिहाल्यो 32 इन्टु नर्मल वेज रेट हेऱ्यो भने ₹50 छ प्लस बोनस कति छ भन्दाखेरि उसको 6.4 इन्टु नर्मल वेज रेट फेरि ₹50 हो इक्वल्स फेरि म क्याल्कुलेट गर्छु अच्छा अब यसको हामीले क्याल्कुलेट गर्दाखेरि यो आउँदैछ 32 इन्टु 50 गर्दाखेरि 1600 प्लस बोनस 6.4 इन्टु 50 गर्दाखेरि आयो ₹320 यसलाई एड गर्यो भने हुन्छ ₹1920 यो कमलको टोटल अर्निङ्स आयो अब हसनको पनि निकाल्नु पर्यो भने हसनको पनि टाइम टेकन 32 नै हो इन्टु ₹50 गरेर नै हो अच्छा बोनस हेऱ्यो भने बोनस कति छ 4 इन्टु ₹50 र 32 इन्टु 50 अघि क्याल्कुलेट गर्दाखेरि आएको छ 1600 प्लस 4 इन्टु 50 गर्दाखेरि ₹200 र यो भयो ₹1800 चाहिँ हाम्रो टोटल अर्निङ्स आएको अच्छा अब क्वेसनमा फेरि के भनेको छ भन्दाखेरि हामीलाई इफेक्टिभ रेट अफ अर्निङ अब हामीलाई यसको रेट अफ अर्निङ्स पनि निकाल्नु भनेको छ है अच्छा यो यहीँबाट कन्टिन्यू गर्छु म इफेक्टिभ रेट अफ अर्निङ्स इफेक्टिभ रेट अफ अच्छा इफेक्टिभ रेट अफ अर्निङ्सको लागि फेरि अब हामी जब यो अर्निङ्स खोज्छ यसको लागि फेरि फर्मुला छ अब हामीले कति अर्न गर्यो पहिला है टोटल अर्निङ्स त खोज्छ हामीले टोटल अर्निङ्स डिभाइडेड बाई अब इच वर्करले कति टाइम दियो उसले है टाइम टेकन अब पहिला फेरि कमलको हेरौँ कमलको अघि टोटल अर्निङ हेऱ्यो भने कति रुपिज 1920 हो उसले टाइम कति लियो भन्दाखेरि टाइम टेकन यहाँ चाहिँ 32 यसलाई फेरि क्याल्कुलेट गरौँ $1920 डिभाइडेड बाई 32 गर्दाखेरि आयो टोटल अर्निङ्स इज ₹60 अब हसनको क्याल्कुलेट गर्दाखेरि हसनको अर्निङ्स छ 1800 उसको टाइम टेकन 32 नै हो सो 1800 डिभाइडेड बाई 32 विल गिभ 56.25 सो अब हामीलाई यदि प्रब्लममा इक्जाम्समा यस्तै प्रकारले तिमीहरूलाई फेरि टोटल अर्निङ मात्रै नभएर इफेक्टिभ रेट अफ अर्निङ्स सोधिहाल्यो भने इफेक्टिभ रेट अफ अर्निङ चाहिँ कस्तो हुन्छ भन्दाखेरि तिमीले कति अर्न गरे टोटल अर्न र इच वर्करले चाहिँ कति टाइम लगायो त्यसलाई प्रड्युस गर्नुको लागि त्यसले डिभाइड गर्यो भने चाहिँ तिमीहरूको इफेक्टिभ रेट अफ अर्निङ्स पनि आउँछ है र यस्तो प्रकारले अब हामीले अलमोस्ट यो च्याप्टरको मैले सबै पार्ट नै कभर गरेँ तिमीहरूलाई डिफरेन्सियल पिस रेट सिस्टमदेखिको लिएर है स्ट्रेट पिस रेट सिस्टम बोनस पनि हेल्सिल र रोवनको पनि गरिहालेँ सो आई होप यतिले चाहिँ तिमीहरूको सिलेबस पनि कभर पनि हुन्छ होला है थ्याङ्क यू